Hello again, welcome to the next section. So first of all, hopefully you can see me. I am wearing camouflage. I know that can make it a little challenging, but I am here, not just a floating head. With that said, this section is I keep saying important, everything's important, but this section is really taking us back to basics in a way. We're talking about data types. So if you remember way back, section 3-ish, I mentioned that we would come back to data types when I introduced varchar, however you want to say it, and integers are two data types we've been working with, which are great. They're very useful, but there's a big world outside of those. What about things like decimals? How do we store currency, price information where we have information after the decimal? How do we store things like dates and time? Well, wait, where'd my watch go? Things like dates and times. There's a lot of information that we need to store that doesn't neatly fit into varchar or integers. So this section is all about introducing and surveying those kind of different data types. And I could have done this early on in the course, but I've done it in the past like that in person, and I find that students get too bogged down just worrying about all the data types when really they need to be focusing on things like create tables and insert statements. That's the focus of SQL and MySQL. We can add new data types easily. So that's what this section is. We have the two we've been working with. Now we're adding a bunch more. A ton of exercises here. Nothing, complex with our data. We're not, using any brand new data set. All we're going to focus on are the data types. We'll see, in particular, we'll focus on dates, times, date times, timestamps, all this terminology. It gets a little crazy, but hopefully we can simplify that in this section. All right. See ya in the next video. Okay. So we're moving on now, and it's time for a brand new section. In this case, we're spending some time revisiting something we've already discussed, which is data types. So very early on, one of the first videos, once we got everything set up and installed, one of the first videos was on very basic data types. And we talked about how data takes different forms, and you have text and numbers, and I kind of left it at that. We talked about varchar and int, our two first data types, but I showed you that there are a bunch more. Well, now is a time that I promised we'd revisit. We'd return to those data types and go into a bit more detail in depth around some of the important data types. So we're still not going to go over every single one because a lot of them are just not used. And some of them are very, very similar with, tiny differences that honestly won't make that aren't relevant to this course. So what we're going to do is focus on what will have the highest impact for you, what has the highest impact in my developer life and the people that I know and have to talk to and about how they use MySQL. So basically it boils down to a couple different data types and a couple different broad categories. So the first category is text or string data types. And then we'll also talk about numeric data types. We have a lot to talk about there because we've only worked with ints. We need to talk about how we store decimal points or how we store, non-whole numbers. Can't remember the term for that. And also, we need to talk about how we store things like dates and times. Really important part of using a database is typically, at least in web applications or applications in general, you're usually storing some sort of date and time information about when a transaction happens, when somebody signs up for your site, the last time something was updated, and so on. So we'll be discussing that as well. But for now in this video, we're focusing on storing text. So as I mentioned, we've already seen varchar or varchar, however you want to say it. I think most people actually say varchar, but I don't know. I say varchar. Doesn't really make sense, I guess. You say character, not character. But all right. So we've already talked about it. It's what we've been using to store text. But there's also char or car, which is an entirely different, separate data type. Now they both store text, but there's one really key difference. Well, what is that difference? Char has a fixed length. So when we specify, let's say we're working with our books table, and we want to have a column called title. We could have, right now it's a varchar in our existing books table, but we could specify it's a char and give it a fixed length of 5 for title. And what that means is that every title that we add in is going to be 5 characters. So if it's greater than 5 characters, if it's 10 characters, it's going to be truncated. It's going to get chopped at that 5 character mark. And if it's fewer, you'll see in a moment what it does. It actually adds spaces to make it 5 characters. So char will always allocate the same amount of space for every row or every instance of that char, versus varchar can vary. And as you can see here, if we did something like char 3, only 3 characters are allowed in this example. So this is taken straight from the documentation, some really boring explanatory text, but it has some important things to know. The length of a char column is fixed to the length that you declare when you create the table. We've already discussed that. The length can be any value from 0 to 255. So the longest char, whatever, that you could have is 255 characters long. When char values are stored, they are right padded with spaces to the specified length. So that's kind of what I was explaining. If we have a 10 character limit, let's say char 10, and let's say I insert something that is only 5 characters, it's going to add 5 spaces after it on the right side of it, pad it with these just spaces to make it exactly 10 characters. However, it's kind of confusing because when you go to look at that string, when you select it back and it's retrieved, those spaces are actually removed, as you can see here. When char values are retrieved, trailing spaces are removed unless blah, blah, blah. There is a way to get them to stay there, but I'm not sure why you would want that to happen. The only reason that I want to point that out is that I think it helps you understand, or has helped other students that I've worked with understand how the fixed length works. If you think in memory that it's actually storing something the same size every time, it's always 5 or always 10 characters, and you can't get around that. So if you give it something shorter, it will elongate it with spaces to make it 10 characters. If you give it something longer than 10 characters, it's going to truncate it to make it 10 characters. So why does it matter? Well, char is faster for fixed length text. So there's not a ton of uses in my experience day to day for using char unless you know for sure that something is fixed length. So I tried to come up with some examples, like state abbreviations is one, at least in the US, where we have 2-letter abbreviations for every state. There's no reason to make that a variable length of varchar. You can save space and time essentially by using char. Or a yes or no flag, Y or N, or any sort of like binary. It doesn't even have to be binary, but something that has a fixed length. So you could do sex in this case if you were doing where a pound or an animal shelter. We're keeping track of animals and their sex. You could use M and F. However, if we wanted to do things like male and female or unknown or whatever other options, those aren't all the same length, so it makes more sense to use varchar. So you could probably come up with some other situations where this would make sense, but typically we use varchar because it gives us a lot of flexibility. Otherwise, use varchar. So there's a table here that I actually took this from the docs. I just kind of blew it up and added it into my slides, but it's from the documentation for char and varchar. And what it's showing you here, for a given value, let's take AB. If we have a column with data type char4, you can see that it adds the 2 spaces, so it's actually stored as AB space space. And if we store the same thing, the string AB, in a column with varchar4, so varchar instead of char, it just stores AB. But what I want to call your attention to is not just how it's stored, but also the storage size, how many bytes it takes up. So if we look at char, when we declare char4, every single string that we insert into that column will always be 4 bytes. And you can see over here, whether it's an empty string, it will convert it to be 4 spaces. If it's 2 characters, it adds 2 spaces. If it's 4 characters, it leaves it alone. If it's more than 4, it truncates it. So we have a fixed size here. However, with the varchar 4, the same values all have different storage sizes. So they're unchanged when they're stored. We don't get spaces added. We don't get anything truncated, which is good. But you can see that our storage size does start to starts to grow as the length of these strings grow. Now, it's not a one-to-one thing. So it's not like if we have a 10 character string here, it's going to take up 10 bytes. But there is a difference. That's all that matters. With that said, to be honest, that difference won't make a big difference. Let me put that another way. That difference is insignificant for most applications that I have ever worked on. If you are working on some giant app, you work at Bank of America and you've got, tens of millions of customers and hundreds of millions of records, that does make a significant difference. But if you're working on a personal project or your own hobby application, you don't really need to fret over this sort of thing. In fact, it's something, sort of a common strategy that a lot of people would say is just get something working, and then when it comes time, you can optimize things. So if you start to realize, well, this one thing is becoming kind of slow, this query I'm writing, or whatever it is, maybe it makes sense for me to make this a fixed length and convert it to a char. Okay, so that's the difference on paper. You can go ahead and skip to the next video. I'm just going to show you in practice what it looks like. So I'm going to hop over to Cloud9, and first thing I'll say, I'm working in just a new database I made, basically just a testing database. I didn't want to muddy the waters with inside of our bookshop database. I wanted to leave that alone. So I just made one called new testing DB. If you want to follow along, just make a new database. Hopefully you remember how to do that. Call it whatever you want. I'm just going to delete it at the end of this anyways. So I'm going to create a table here. And all I want to do is have two different columns, one that's a char, one that's a varchar. We'll just do dogs, let's say. Create table dogs, and we'll have name, which will be char of fixed length, 5 characters. And then we'll have breed, which will be varchar, and let's just say 10 there. Okay, just like that. And we'll go ahead and hit enter. And I'm missing a comma. There we go. Okay, so we have that dogs table. Now let's insert some simple data. So the first thing that I'll do is insert into dogs. And remember our syntax here, it's been a little while since we've inserted. We've been doing a lot of selects. But we need to have our values. And the values that we'll pass in, we're going to start with something that is less than 5 characters. So for name, let's say Bob. And breed will also be something short. Let's say, what is a short dog breed? Beagle, I guess. I don't know. Okay, so we'll do that. And we'll do one more here. This time we'll have a name that's exactly 5 characters. Let's call it Robbie, spelled that way. I apologize for unoriginal names here, just trying to work with the constraints. And breed here will be Corgi. Okay. And we'll do one more, and this time we'll have a long name. How about Princess Jane? And Princess Jane is I'm totally at a loss here. What's another breed? Let's go with Retriever. Did I spell that right? I never remember. All right, forgive me if that's spelled wrong. Okay, so first thing first, right off the bat, notice we got a warning on this last one. Why do you think that happened? Well, it's because Princess Jane exceeds the limit that we've set for our char, which is 5 characters. So now if we do a simple select star from dogs, you'll see we have Bob, Robbie. They look good. They look the same, unchanged. And Princess Jane, unfortunately, has been truncated. So unfortunately, we can't actually tell that there are those trailing spaces because they are not actually here when the text is retrieved. Remember what that giant blurb of text said. It said that they're stored with these 2 extra spaces in our case, because this is 3 characters and we set up a 5-character fixed char. So there in memory are going to be 2 spaces here, but when it's pulled back out and displayed to us, they're chopped off. Robbie is unchanged because Robbie is 5 characters long. Princess Jane, unfortunately, is cut off. However, when we look over here, Beagle, Corgi, and Retriever, varchar works how you expect. It's a variable character length. Let's just do one more example here with Princess Jane. Yeah, we'll just have another Princess Jane and a long Retriever, blah, 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 blah. Now, when I do a select star, notice again what happened. This is what we expect to happen. We've already seen this, how varchar works. It still has a maximum length that we can provide. In this case, we did 10, I believe. Yes. So it can work similarly to a char in that sense, where it will truncate things. So just to wrap up the end here, char, again, is faster for fixed length text. So if you know something is always going to be the same size, use char. However, if you have any doubt, use varchar. And again, the difference is relatively insignificant for most of the things. And I don't want to be presumptuous, but most of the time, it's not going to be a deal breaker. Okay, so moving on, we're now going to discuss numbers in the next video, not this video. Okay, so next up in this onslaught of data types, we're going to discuss some important numeric types. So there are quite a few. We've already discussed int. We've used it quite a bit. It works with whole numbers. So it's useful if you're working with things where you need them or want them to be whole numbers, where decimals don't matter. So we know how int works at this point. However, there are a bunch of other data types that MySQL comes with. We're not going to talk about every single one. We're just going to talk about the ones that will matter the most. And in my opinion, those are, or the first one is decimal. So decimal is what it sounds like. It's a number that includes a decimal afterwards, or how can I put this? I don't think that's the right way of saying it. It's a number that includes a decimal point and something after it, or it can include something after it. So when we create a column, we actually provide 2 arguments, and we'll talk about those in just a moment. But the important part here is that it's a way of creating a column that will store numbers that include decimals, something after the decimal point. So what are these 2 numbers we're passing in? Well, on this next slide, I have a handy little graphic here. When we run, or when we create a column, let's say, let's call it price. This is a price of let's work with books, or books price. We have 2 different arguments. The first one, 5, tells MySQL the maximum number of digits that our number can have. So that actually includes both before and after the decimal point. And then the second number is how many digits come after the decimal point. So another way of looking at it is something like this. Here's the maximum number we can store in a decimal 5,2. So it's 5 digits long. 2 of those digits are after the decimal point. And if we hop over to the documentation, which I'll try and hold my tongue, but I definitely find to be occasionally subpar, it does an okay job here explaining it. So the declaration syntax for a decimal column is decimal m, d. M is the maximum number of digits, the precision. It can go up to 65. D is the number of digits to the right of the decimal point, also called the scale. I've never heard anyone actually use those terms, but I guess it's good to know. And it has a range of 0 to 30. So there can be no more than 30 digits after the decimal point, which in most cases is going to be plenty. I mean, way, way, way more than you pretty much ever need. So that's the gist of decimal here. It lets us store numbers that have decimals, but we do need to specify roughly what those numbers need to look like. So we'll create a very simple table, let's say a generic item. So items, and all we're going to have is a price. We won't even worry about a name or anything. So we'll have a column called price, which is a decimal. And let's go with what we saw there, 5,2, just like that. Okay, so we have that now. Let's insert a couple things and test it out. So insert into items. The first one that we'll do, well, we need to specify price. and then values. And the first one will be just a whole number. Let's say 7. Just like that. Okay. Then let's do a long whole number like that. See that we get a warning. Then let's do 34.88. Then let's also do a 298.9999. And finally, let's do 1.9999. Okay, so now let's do our select star from items and see what we have. Okay, so the first thing that you'll notice is when we inserted 7 without a decimal, it added those 2 decimal places for us. And again, that's because when we created the table, we said there are 2 places after the decimal. So it adds those in, even if it's a nice whole number. This next one is a bit weird. We never inserted 999.99. We inserted 7987654. So what's happening here is that this is much larger than the maximum number allowed. The maximum number allowed, as you can see here, is 999.99. Because we specified it's 5 digits total with 2 coming after the decimal. So that gives us 999.99. So good to know. When you do this, if you create a number that's too large, it's going to just put the largest possible decimal given the constraints you set up. Then next up, we have our 34.88, which looks just the same. And then we have 298.9999, which you'll notice here is actually rounded up. So it's rounded to 299, and that's because we specified rounding to 2 decimal places. And when we do that, it's going to round up, and that will round up, and so on. Well, actually, it's on this one here. It will round up to 299.00. Same thing applies here, where we have 1.9999. So that's the basics of the decimal data type. Pretty commonly used. I'll be using it throughout the course. With that said, there are other data types that we can use to do the same thing that we're going to talk about in the next video, and we'll discuss why and when you would use each one. Okay, so we discussed the decimal type, and you've already seen the int type, but we're focusing on the decimal type, or we did focus on it, but like I said, there's a bit of competition. So there are other types that we could use to represent similar data, which is to say numbers that are not whole numbers. So there's also things like float and double. So we're going to talk about those in this video. The differences, I'll have to be upfront, between all of them are quite technical. They have to do with how things are stored in memory. It would be difficult to explain without going all the way into how binary works, and base 10 versus base 2, and how things are stored in memory. So I'm going to kind of skim over some of this because the honest answer is that it doesn't, or the truth is that it doesn't really matter. All that matters is that you know functionally what the difference is. But if you do want to learn more about the difference between them, there are some good resources online, and I highly recommend that you check out some YouTube videos. And I would love to link you to a specific one. However, I've had some copyright claim issues, so last time I did that, I'm not going to do it now. If you're curious, you can research it. But essentially, like I said, it boils down to how they're stored. So the big question is, what's the difference between float and double, let's take them as a unit, and decimal? And if we go to the documentation, there's a page that lays it out relatively plainly. It says the decimal data type is a fixed point type and calculations are exact. The float and double data types are floating point types and calculations are approximate. So we've got fixed point and floating point. They are different. That has to do with how what I was describing, how they're stored in memory is different. That's not as important. Just knowing that they are different is important. However, the side effect of how they're stored is that float and doubles are approximate, which seems kind of weird. It doesn't seem like you would ever want to use them if they are not exact, but essentially they're approximate, and decimals are exact. So to boil it down, float and double will store larger numbers using less space. So that's an advantage. They can take gigantic numbers, things that you can't store in a decimal, and they'll use less space. However, that comes at a big cost. It's a big but. It comes at the cost of precision. So it doesn't mean that your numbers will be wildly inaccurate if you're using a float or a double, but it does mean that they're not going to be as accurate as a decimal. So here's a simple table that it just basically takes information from the documentation. Floats will have precision issues after around 7 digits. So if we had something like this number here, we could run into a problem where this 1 might not reliably be 1 when we retrieve it. It might change. And that could be problematic if you need it to be precise. But if you're working with gigantic numbers, something like this, or let's even add in something like this 1 at the very end isn't going to be a deal breaker most of the time, depending on what you're working with. With that said, it's really important to know that there is a difference, and there's a lot of kind of classic bugs and issues people have run into. Lots of blog posts around floating point math problems, or floating point math issues and bugs. Doubles are basically the same thing as a float. They're just bigger. They have larger capacity. However, they take up more space in memory. As you can see, 4 bytes versus 8 bytes. A double, however, is more precise. So it's precise to roughly 15 digits rather than just 7. So if you do use one of these, it's better to use double. Which brings us to the question, what numeric data type should you use when you're storing information that has a decimal? And the answer, at least in my opinion, is you should always try and use decimal unless you know that precision doesn't matter. So if you're doing things like financial data, prices, if you're a bank, you need that precision, absolutely you need to use decimal. Otherwise, you can get away with floats or doubles. But for the most part, I'll be using decimal. It's kind of my preferred data type when we're working with decimals. Oh, and before I forget, well, actually, I already forgot, but this is after I recorded the video. I'm going and adding this in. I wanted to show you that you can actually see the inconsistency, the impreciseness of using floats and doubles as well. So I'm going to create a simple table, and I will just call it, let's go with thingies. Why not? Create table thingies, and all that it's going to have in there is a price, which will go with float. Okay, so then we'll do our insert into thingies, and we'll do, well, we need to do price, values, and let's start with a simple one. Let's do 88.45. And if we select that out of there, good, we get 88.45. But we'll run into problems if we start making more complex, longer numbers. So let's do something like 8877.45. And that should still work. And if we select it out, you can see it's unchanged. Remember, we're working with 4, 5, 6 characters here. And if we go back to that table that I had, it says around 7 issues we run into precision problems. 7 characters we run into precision problems. So if we do something a little longer now, 8877665544, and we hit enter, notice how it got stored. So it doesn't just truncate it, doesn't chop things off, but it only stores the first 7 digits, and then it just puts these empty tens places, well, not tens places, but it multiplies by 10, adds zeros essentially at the end. So we end up with this, which is very different than this. And if we instead had this as a double instead of a float, we would have that precision extended out to 15 characters. So it is significant, and it makes a big impact depending on what you're doing and what you need. So that's why I recommend using decimal, where you can control exactly what you need and how long you need things to be. However, if you're working with gigantic numbers and you don't need to be that precise, you can use double or float. But typically, my rule of thumb is if you need to use one, use double rather than float, because you have 15 characters, 15 places of precision rather than 7. You get double the precision. Okay, all right. So we've made it through that war zone of string and number types in particular. The number types are always a bit hairy, but we're moving on to something equally finicky, dates and times. Often the bane of many programmers' existence, having to deal with time zones and synchronizing things across the world and daylight savings, and it's just a nightmare. Leap years. Fortunately, MySQL makes it relatively simple for us. I'm going to show you how in just next couple of videos. So this is going to be a series here, not just a single video. And in fact, in this first video, I'm just going to give you a quick overview of the 3 important data types that we'll take a look at. So the first one is called date. And what it does is it just stores a date without a time. So the format looks like this: year, dash, month, dash, day. So 1999-11-25 or something. So as it states here, that stores a date but no time. So there are instances where you may use this, things like a birthday, if you're asking a user to sign up and specify their birthday. Most users don't know the time. Well, I don't know. I don't know the time I was born. I know a lot of people do, but it doesn't matter. At least for most websites, it doesn't matter what time someone was born. You just need that date. Another option is the opposite, the time. So time is another data type that stores values with a time but no date. So out of the 3 I'm going to show you, this is the one I use the least by far, because there's not many things that you just need to store a time. Maybe if you're, I don't know, if you're working with reminders, maybe or working, I'm at a loss really, but basically you store times, and the syntax, the format is hour, dash, colon, minute, colon, second. And the final data type, and the one that I use by far the most out of all of them, is date time. Not very creative, I know, it's just date plus time. It does what it sounds like, which I also realize I'm saying way too often in this course, but it stores values with a date and a time. And this is pretty useful. You get both. And like I said, this is what I use the most. So when you're doing things like, when a user signed up for your site, or when something was last updated, when a profile picture was last updated, or when somebody commented on a Facebook post, those are all stored with date times, because just having the time on its own isn't that useful. So let's go with this Facebook example. If I comment on someone's post, Facebook doesn't just store the time that I commented, 10:39 p.m., let's say, because it's just not that useful to them. I think what Facebook does, it displays things like how many days ago or hours or minutes ago or something, I commented. It will say Colt commented 3 seconds ago, 20 minutes ago, 2 days ago, last month. And it needs more than just a time to figure that out, right? It needs a time and the day. So date time, very, very useful and used all the time in applications. And a really common use case in programming in general is when you have a column, or let's say a row in a database, in a table, and it's created. You often want to just store the date and time it was created so that you can then go and sort things based off of how new they are and how old they are. So very easy, if you're working on comments, for example, going back to Facebook comments are displayed in the order that they were written and posted. So you need to store that created at time. So that's where date times come in. And the format is also what you probably expect. Year, dash, month, dash, day, which is the date part, and then a space, hour, colon, minute, colon, second, which is the time component. Okay, so we talked about those 3. We didn't see them in action, but we saw that they exist: date and time and date time. And again, I use date time the most, will be using it the most. It's the most versatile and the most useful. So now that you've seen the three data types we're talking about here around dates, which are date, time, and date time, let's hop over to Cloud9 and just try them out briefly. So what I'm going to do is actually make a new table. And in this one table, I'm going to use all three types, three different columns, of course, so that we can compare and contrast how they work. And you'll see that they're pretty similar, honestly, which is why I didn't want to make three separate videos, because it would be pretty boring. It'd be a lot of repetition. So let's go ahead and do this. Now we're going to make a table called people. And in people, we're going to work with, we'll start with name, which will just be a varchar. So somebody's name. Then we're also going to have birthday as a date, birthday as a time, and birthday as a date time. Of course, we can't just call it birthday 3 times. So we'll start with birth date is a date. Then we'll have birth time is a time. Finally, birth date time is kind of annoying. Let's just do DT is a date time, just like that. Okay, so we have that table now with name, birth date, birth time, and birth DT. So we're not going to spend a lot of time adding data in, but let's insert at least 2. So let's do an insert into people, and we'll start with name, birth date, birth time, birth DT. Okay, just like that. And then on a new line, this is going to be the worst part. So let's make up a date. Well, a name, first of all. Let's say Padma. And then the birth date. Remember, we need that year, dash, month, dash, day format. So we will do 1983 dash, let's do 11. So that's the birth date. Then the birth time needs to follow hours, minute, second. Well, hour, colon, minute, colon, second. So let's say 10:07, 35. And then if we want to be accurate for the date time, we would basically combine these two. So we would have 1983-11 space in the same time. Okay, so that's kind of annoying to type. You're usually not doing things like this, to be honest, but let's just make sure we don't have any typos. We're not missing any quotes. We'll soon see. Oh boy, we do have a problem. And this is a silly one. We're missing the values keyword. Hopefully you caught that before me. Okay, so I'm just going to recall that and just change some information so we have 2 people in there. So we had Padma. Let's put Larry, who was born in 1943 and on December 25th, on Christmas, at let's do 4:10:42, and then we'll just copy this so we don't have to retype that whole thing. I apologize. This is a little bit painful to sit through. We're not doing much, but we need some data to work with. Okay, so that should be sufficient now. Just make sure that matches up. All right, so now we do a select star from people. We have 2 people in there, and then we're storing birthday information 3 different ways, although they're not equivalent, of course, because we have just the date, just the time, and then the date and time together. So now that we have this data in there, we're going to focus for a couple videos, pretty short videos, on how we can work with this data. There are some functions that come with MySQL, and we've seen a bunch of them, but there's some that work with dates and date times, and we're going to focus on those to do things like format our data nicely. So how do we format dates? How do we get the day of the week based off of someone's day they were born? Things like that. How do we print out a nice version? This is a little bit ugly. And then also, how do we do math with dates? Now, we're not going to do any heavy duty math, but things like calculating how many years it's been from 1943 to now, or how many days since Padma was born, those sort of things. And we'll be able to do that now because we have this data in here. So thanks for sitting through that. I know it's probably a bit painful. Hey there. So I have a small confession to make at the beginning of this video. This is not my first time recording this. I recorded this about a month ago along with all the other videos in this section, and something happened. I didn't save it correctly. I maybe accidentally deleted it. My cat stepped on the keyboard. I have no idea. But the original video here is gone. And normally that wouldn't be a problem. It's happened before, or I just re-record a section because I'm not happy with it. That's not too bad. It's easy to do. But since this has to do with dates, and in particular, it has to do with these 3 date functions that I'm going to show you. Basically, they give us the current date, the current time, and the current date time. You'll see in the videos following this one that the code that I ran when I was recording it the first time resulted in different dates and different times than what you'll see right now. So it's not a big deal at all. It's just evidence that I recorded them on different times, but I wanted to just let you know what to expect. Okay, so in the last video, we inserted these 2 where we manually created, or basically wrote out the dates, the time, and the date time. And then in the initial recorded version of this video, this is the new person that I inserted. And this birth date, birth time, and birth date time were all done using these 3 functions here that give the current the current date. So at the time it was April 21st, and the time was 7/12, and this was the date time. And so I used these to generate this. So in the next video, you will see this person with toaster, birth date, April 21st, and so on. But in this video where I'm actually showing you the creation, I'm having to re-record it. So there's just a small discrepancy. Other than that, everything else will be the same. So let me show you these 3 methods here. They're really useful, simple things, but cur date gives current date. As I said, cur time gives the current time. And then now gives current date time. So let's try one of them just on their own. If you did something like select cur date, you'll see that I'm actually recording this on 5/12, May 12th, so not quite a month later, but a couple weeks later. So if we do the same thing with cur time, we get the time. And then if we do now, we get the date time. So using them on their own is not useful, really, just to select the current time. It's much easier just to look at your watch. But they become useful when we use them in conjunction with insert statements. So things like when we're inserting a new user and we want to save the time that the user was inserted. What we could do is basically write an insert into, and we'll do people. Let's do our select star from people. Okay, so we'll do insert into people, birth date, birth time, and birth date time. And so I think the hypothetical story I gave was that Toaster was my son, my first son, and he was born exactly at the moment when I hit enter. So we'll do the same thing here. Inserting into people, birth date, birth time, birth date time. This will be my new son, and this one's name is, let me actually add name as well. Oh boy, I'm really bad at naming things. You can tell I named my cat Blue, which is Blue Steel, by the way, if you didn't catch that. Okay, so I'll name him Microwave. And then rather than writing out the giant date here, what I'll do instead is for the birth date, I just say cur date. And then for the birth time, I'll just use cur time. And then for birth date time, I use now. And out of all of these, I end up using now the most often because, as I've mentioned before, we use date times a lot. Okay, so if we just run this right now and insert that, and now we do our select star from people, you can see that microwave now has the date, the time, and the date time that reflect exactly when I inserted this just a couple of seconds ago. And that's pretty much all there is to these three nice little functions. Another way that we use them, by the way, is not just to insert data with current dates and times and so on, but also to compare data to the current time. So I'll show you how to do some basic date math. We'll be able to figure out, how long ago something was compared to now. And so we need to be able to refer to now, or we want to figure out how many dates, how many days somebody was born ago compared to the current date. So we need that current date in order to help out with that math. Okay, so the last thing I'll do here just for continuity's sake is delete microwave so that we have toaster, Larry, and Padma, which is what I had in the original recording, so that the next video here hopefully will be relatively seamless. So I'm getting rid of my son. I'm sorry, microwave. I failed you. Okay, so now he's gone and we're back to these three. All right, so that's cur date, cur time, and now. All right, welcome back. So in this video, we're continuing with dates. Not the most exciting topic potentially, I know, but an important one nonetheless. So we're talking about formatting dates. Right now we have dates, times, date times, all stored in a somewhat clunky, condensed, but difficult to read, at least for human, difficult to read format. Just not very nice. So how can we extract things out of, let's say, a date time? How can I convert that so that it says something like April 21st, like the full month name, followed by a space, 21st 21st, and then the full year, rather than, 2017-04-22. So we're going to do that. First thing I want to show you, though, is that in the documentation, there's a pretty massive list of date and time functions. And I will be honest with you, most of these I never use, and you likely will never use. That won't stop me from showing some of them to you, and I'm going to try and highlight which ones are most important. And the first few I'm going to show you, I don't actually think are that important, but they are nice to know that they exist. And they're a set of these one-off little functions. I'm not sure even what to call them, but basically there's a group of them, at least in my mind, I group them together. Things that will extract an individual piece of information, like day, or day name, or day of month, day of week, day of year, hour, month, minute. So let me show you what I mean. So I'm going to hop over to Cloud 9, and we have a select star. Let's only work with birth date for now. So we'll do select name, comma, birth date from people. Okay, so instead of displaying the date here, or the entire date, what I can do is use some of those things that we talked about, whatever that group is. Let's try day. You'll see what it does. So rather than birth date, I'll select day of birth date. And all that it does is extract the day. So if we compare, actually what might be better is if I keep birth date and I just add in an extra column with day. So it's extracting the day, 11, 25, and 21. So there's other things we can do. Let's just go with this list I have up here, day name. And this is a bit more useful. There are times when you want to do this. As you can see, we're extracting that. So turns out this is a Friday. This is a Saturday. And this is another Friday. I know some people can figure this out mentally. There's a whole trick to doing it. I'm not one of those people, so we just have to trust it that this is indeed a Friday. Moving right along, we can try day of week. And you might wonder, how is that different? Well, it gives you a number. So a Friday is a 6, a Saturday is a 7, a Sunday is a 1, and so on. Then we also have day of year. And that will tell us, starting from the beginning of the year, how many days was it until, oh boy, messed up the parentheses. Here we go. Until that date. So for something on Christmas of 1943, it was the 359th day of the year. Oh my God. Blue, come on. blue. And this, of course, takes into account things like leap years. So important to know. With that said, these also apply to date times. So if you tried to do it on time, if we start right there, instead of doing birth date, and you tried to do birth time, well, there's going to be an immediate problem, which is we're not storing day of the year or day information at all. But just to show you, we don't get an error, right? We get warnings, but we don't get something that breaks everything. We just get null. It doesn't work. But we can do it on a date time, and that's what, like I said, I use most of the time. So if we do birth dt instead, you can see that it's giving us the correct numbers here, 359, 111, and so on. So we can use all of the ones we've seen, day name, but there are other things too, briefly, that work for date and date time. So things like month. So that tells us the month. What else is there? I think there's a month name. Yep. So if you want the full name of the month, there we go. And then lastly, when we're working with the time, so if we go and change this to birth time, there are a few methods that apply here. We can do things like hour, if we want to extract the hour, or minute. Now, I don't end up using time on its own that often, so I don't really end up using these, minute or hour or second, on their own ever, really. So that's part one of formatting dates. Imagine if you wanted to do something like this. Instead of just printing out, the day or something, we wanted to say April 21st, 2017 at, 6 p.m. maybe. Or we don't even need that. Let's just say April 21st, 2017. So how would we take this date, that would be 2017-04-21, and convert it to this? Well, we could use what we've already seen and do a giant concat. I won't make you do this entire thing, but basically we could extract the month name to get this, and then concatenate that with a space. And then this part's a little trickier, right? It's going to be a pain, honestly. You would have to have some logic that I haven't shown you how to do yet, because you don't always add st after a number. What if it's a 23rd? So that's a little bit more complicated. So let's reduce it to this. So for that, we would want to get the day, right? And then we want the year. So you could do a giant concat. Basically, we would take all of these for birth date. This is going to get messy. And the point is that there's a better way. But imagine you're doing this. So we have a concat, month name of the birth date, comma, with a space, comma, the day of the birth date, comma, another space, comma, the year of the birth date. This is a bit of a mess. But let's see if it does work. So we'll just select that from people. There we go. November 11, 1983, December 25th, 1943, or 1943, April 21, 2017. So it does work, but this is not a great way of formatting dates. And in fact, there's a much better way, which you probably gathered because the way that I set this up. There's an entirely separate method or function, that we can use, which is called date format. So date format is really, really useful in my opinion. I use it all the time. What it does, it looks a little intimidating looking at the documentation, but what it does is it allows us to format things nicely and powerfully. We have a lot of different things that we can do. So these are called specifiers over here. There's a table of them, and they're basically little symbols, little shortcuts that allow us to specify what we want from that date. So let's say we're working with a date time, and if I want to get the month name, I use %, capital M. And if I want the month number, then I use %, lowercase m. If I wanted to get the day of the week as the weekday name, I use % uppercase W. If I want the day of the week as a number, I use % lowercase w, and so on. So what we do is combine them together in a string. And when you pass it into date format, it will take a date and then the string of how you want to format it, and it will spit out a nice answer for you. So here's an example. Excuse my fridge there, or my ice maker, I guess, being noisy. So we've got date format of this date time here. It works on date times and just plain dates. So here's a date time though. My fridge making so much noise. Okay, I think it's done. So we have this date time, and we're formatting it with this, which looks a little bit like gibberish. But we have % uppercase W, which gives us the day of the week as the word, the name of the day of the week, and then a space, which gives us that space. Then we have % uppercase M, which is the name of the month. So we have October, and then another space, and then we have % Y, which gives us the year. So really useful and versatile. I'm just gonna copy this one over, just run it so that you can see what happens. If I hit enter, we get Sunday, October 2009. But we're free to put whatever we want in here. So we can do dashes, not that it really makes sense, but if we put dashes there, it still puts the important information here that we specified, but now they're separated by dashes. So it gives us some freedom. We can do, group them together like that if we wanted to, put commas, or we could put an entire word before or after. We can do whatever we want. So this is really, really useful. If we go back and select, let's work with date time. So we'll do select date format, and then we're working with birth DT. And then some string that we'll provide in just a second. We'll come back to that. From people. We can start with something really simple, like just getting the day of the week as we'll do day of the week first as a word. So uppercase W. We could do something like was born on a Friday, a Friday. But as you saw, there are a bunch of other things that we can do here. We can work with hours and minutes. We can work with seconds, month names, tons and tons of things. It's really versatile and very useful. And typically the things that I end up doing with it are just formatting dates so that they look like, at least in the US, where we put the month first, followed by the day, followed by the year. So that's pretty simple to do. Think about how you would do it, though, if you want to give it a shot. How do we take this and change it into that? So we can do that now. All that we want is the month number, right? So that's %M, I believe, followed by a slash, and then the day, %D, followed by the year, which is %Y. Let's see if that works. Almost. If you notice, I use lowercase y, and that gives us the two, I don't know what you call this, the abbreviated year, the last two digits of the year. So we want uppercase Y, and I just happen to remember that, but if you couldn't remember how to do it, you can consult this. And we'd find it, where's that? Year, numeric 4 digits versus 2 digits. So let's wrap all this up. We talked about a lot of different ways of formatting dates. I frankly don't use these that often, like I said, because you can do the same thing using date format. I should mention there's also a time format. It works exactly the same way. You just pass in a different formatter here. So you're not going to be able to get month, day, and year from a time, but that you can get hours, minutes, seconds. But like I said, I'm not working with times as often. And if I am using a time component, it's within a date time. So I might do something like this. And let's say let's just do hour and minute. And we'll put a colon there. And there you go. So I'll do something like that, but I'm rarely working with just a time, but there is a time format if you do need to do that. Okay, so back to where I was wrapping up here. There are all these weird one-off functions. I don't use them though because you can just replicate it using date format. And it's much easier for me just to remember one function, date format, rather than 15 separate functions. So that's the basics of formatting dates. Next up, we're going to talk a bit about doing math with dates. All right, welcome back. So in this video, we're going to talk about date math. How do we add dates, subtract them, figure out how many days are between two dates, for example, or how many minutes, or take a current date and add, 10 minutes into the future or something like that. It's a pretty common thing to do, especially when you're dealing with comments or blog posts or some sort of information where it makes sense to display how long ago something was created. On Facebook, I think I've been over this before, but Facebook will tell you this, you commented on this 10 minutes ago, and then you come back the next day, it will say 1 day ago. And then a week later, it'll say a week ago. And then at some point, it transitions over just to the date. It will say December 5th or something. So you can accomplish that by using some of the tools I'm going to show you in this video. Now, we're not going to spend a ton of time on date math because it's not the most exciting thing. Also, date math sort of sounds like, like at the end of a date, fighting for the check, figuring out who pays for what. Anyways, yeah, it sounds like a bad band name or something. Date math, though, in our context, there's two main functions we're going to talk about. And the first one is pretty simple. It's called date diff. No underscore, it's just date diff. It stands for date difference. And what it will do is it takes two dates. So here's an example one, a date time, which I should highlight. Pretty much everything in MySQL that has date in the name will also accept date time. So, okay, here's a date time, and then here's a date. And when you subtract them, it turns out they're 1 day apart. So this always tells you the number of days. So it's not going to give you minutes or seconds or months or something. It gives you days. And then if you wanted to, you could turn that into months or something. However, its primary purpose is to give you the number of days. So let's try it. We could do something like this. Let's work with our star from people. Let's work with that. And let's figure out how many days ago each person here was born. So it would be something like select date diff. And then we want to take now and subtract birth date. Hopefully that makes sense. We're taking now. We could also do cur date. It wouldn't make a difference because we're not working with the time part of now, but I like now. It's a short, easy to remember thing. So select date diff now, or comma birth date. So that will take current date, subtract birth date, and find the number of days. Let's try it. Okay. So let's make this a little bit clearer. Let's do select date diff, and we'll also display name and birth date. Here we go. So Padma, born in 1983, 12,215 days ago. Larry, born the longest ago, 1943, is 26,781 days old. And then Toaster, who was just born today, is 0 days old. All right, so that's all there is to date diff. The next thing we're going to take a look at is date add, and there's a little bit more to discuss there. If we just look through the docs, date add, conveniently right below date diff. We've got another table here, like we did when we had date format. There's a bit to discuss. So what this allows us to do, it is kind of the bread and butter for date arithmetic. So we specify a date, so date add, and there's also a date sub for subtract, but we're just going to work with date add for now. So we give it a date or a date time, and then a comma, And then this sort of weird syntax that basically specifies what we want to add. Do we want to add 10 days, 1 year, 4 quarters, or 3 quarters, how about? 18 months, 10 microseconds, whatever it is. The way that we specify it is using the interval keyword. And then we pair it with one of these units and then put it all together. It looks something like this. So if we have this date time, or actually let's take a look at this example here. Date add, here's a date time. And if you want to add 1 second to it, you just have to say interval and then second, which is the unit, and then how many seconds. So it follows that format. Interval 1 day. And then it gets kind of weird when there's things like minute, second. So this will do 1 minute, 1 second. Add that to this date time. Pretty nuanced thing. I've never had to use these ever, but good to know that they exist. So let's give it a shot. Let's work with, let's do months. So we'll go here. We'll do a select. And let's do date time this time. So select birth, date, time from people. Just take a look at what we have. All right. And now let's try also doing a date add, birth, date, time. And we want to add 1 month. So we have to say interval 1. And if you can't remember, you can go over here, month. It's pretty straightforward. Okay. So as you can see here, we go from 1983 11/11 to 1983 12/11. Or here, 1943 12/25. Here's a significant month, where we went from Christmas of 43 to January 25th, 44. So we can also change that over and do things like, rather than 1 month, what about 10 seconds? You'll just have to trust that that works. We can look at it, but I won't spend time in this video doing that. We could also do things like 3 quarters. And you might be wondering, okay, that's great. What if I wanted to do, multiple things? Like I wanted to add 1 month and a year. Or I wanted to add, 10 years and 2 seconds. Well, the easiest way to do that is with 2 separate date adds. You can't just chain them together like this, 2 second or something. That doesn't work. However, there's a nice shortcut that I'll show you right now, which brings us to our third way of doing date arithmetic, which is just with the plus and minus sign. So if we go back to the docs, you can actually see that rather than using date add or date sub, which I didn't go over, but it works the same way as date add, except it subtracts things. You can just use a date and then the plus sign and then the interval expression and a date and a minus sign. So we could rewrite what we did as, if I go back here, this one where we added 1 month. All I need to do, if I get rid of the date add, is just do birth, date, time, plus sign, interval 1 month. As you can see there, it still works. Or I could do, let's subtract 5 months. And this takes us back 5 months, 5 months, and 5 months. All right. So the only other thing that I'll show is that you can chain them together this way, so that you could do something like take a date time and add interval 15 month plus interval 10, let's do hours. And if you take a look, we're not only adding 15 months, but if you look at the time portion, we went from 10 to 20, 4 to 14, 19 to 5. So we're adding 10 hours successfully. So this is my preferred way for doing date math. I will say though, it's not that often that you're doing things like adding 15 months or adding 10 hours. More often than not, I'm actually using date diff and finding how long ago things were relative to now, relative to current time. Okay, so that's pretty much it for date math at this point. The last thing that we're going to talk about in the next video is how we set up timestamps. So a new topic, how do we automatically store when a row is updated, what time it was updated at? So we'll see that in just a sec. All right, so this is the last bit of new content around dates and date times and times. I admit that this section is a bit of a doozy or a pain, or I don't know, it's maybe not the most exciting thing. With that said, this is a really important topic what we're going to discuss here. And it's something that you'll be doing all the time, or probably will be doing all the time. I do it all the time, which is adding in timestamps to our tables. So when we say timestamps, there's two things to unpack. One is that that's a generic term that just refers to storing information, metadata about when something is created or updated at. That's sort of a standardized name across programming languages or across just in programming in general and in app development. Timestamps refer to basically saving information about when you create a post or when you insert something into a table. However, in MySQL, timestamp is also a data type. So yes, I know it's the last video in this section, but I'm actually going to show you another data type. So hang in there. Fortunately, this data type is really simple, and there's only one case that I recommend that you ever use it. Okay, so there's a page called the date, datetime, and timestamp types. We're going to ignore date. We've already talked about that. Let's compare datetime and timestamp. They both do the same thing. They store date and time information, but there's two differences. If we read the description, datetime is used for values that contain both date and time parts. Yes, we know that. The timestamp is used for values that contain both date and time parts as well. So they're identical in that sense. But the main difference comes down to the range of times and dates they support. So if we look at date time, it goes back to year 1000 and all the way up to year 9999. Timestamp, on the other hand, only goes back to 1970 and up to 2038. So that's really important to note. If you are working with something where you're storing dates that may go back very far, like if I'm trying to think of a good example, but things before 1970, certainly you might have sites where you're storing a birth date, and you might have users who are older than that and they're born in the 60s or the 50s. So timestamp would not work. Same thing going forward. If you're working with dates and date times where you need things to be further into the future, past 2038, then you're not going to want to use timestamps as well. But for what we're talking about, just saving when something is created or when it's most recently updated, we don't need to worry about that being before 1970 or after 2038 because it's right now or when our app is up and running. Now is relative, but basically it's not going to be past 2038. And we're not changing those dates. All that we're going to do is store information. So timestamp is a good data type to use there. And you might be wondering why use it in the first place. Why does it exist if there's already date time? The answer, like so many things in MySQL, is that it just takes up less space. I believe it's 4 bytes compared to 8 for date time, or it might be, it's double to use date time compared to timestamp. I believe it's 4 and 8. So it's easier. And if you're doing something, every time you insert something into a row, you are updating something. That 4 versus 8 makes a difference if you're working with thousands and thousands or millions of records. So now that we've got that out of the way, just to summarize, they store the same type of data. This one is smaller. Timestamps take up less space, but they have a more limited range. So use date time for everything except for what I'm about to show you. Okay, so let's hop over to Cloud9. Here we are. And I have a simple schema going to create a table called comments. Comments is very simple. It has 2 fields. The first field is called content, and it's just the content of the comment. Things like great article or I made $1,000 a week working from home, learn how, email me, or whatever spam comment there is. And then, this is the important part, created at, which is a timestamp, first thing to notice. It could be date time, Just want to make that clear. You can do that. It will work. But we're using timestamp because this is basically what it's intended for. And it takes up less space. So just setting it to timestamp on its own is not that useful. This is the key part. Setting the default value to be now. So whenever it's created, take that now, that current time, and put it in timestamp. So if we run this schema right now, and we insert a few things, so let's do insert into comments. All we need to insert is content. And what we'll do is just insert our first one. I'm going to do them separately so that they have different timestamps. So the first one will be LOL, what a funny article. Something silly like that. Then let's do another one like I found this offensive. Okay, so now if we do select star from comments, you can see LOL, what a funny article, created at, already filled in automatically today's date, the time, 36 seconds. Compared that to I found this offensive, same date, same time until we hit seconds. It was created 10 seconds later. So that's created at, and of course, that's really useful. I would show you how to sort them. However, they're already sorted here, as you can see, because the order I'm putting them in is sorting them. But let me just try one more. Let's do just some gibberish. Select them all. And now we can do things like order by created at. And that will order them basically the way they're ordered now, but we can reverse that. Change that to descending. Now we have the most recent comments up top. So that's created at using default now along with timestamp. But what if we also wanted to store anytime a field was changed? There's an easy way to do that as well. Just scroll down, magically hidden here. So instead of calling it created at, I made a new field called changed at. And the first part's the same. It's a timestamp and it sets a default value to be now. But then we get this on update, which we haven't seen before. And frankly, this is really the only time I ever use it, or I don't know, I'm trying to think if I ever used it in another capacity. Pretty much this is the only way I've seen it used. On update, current timestamp. So what this is saying is that when the row is changed, so if content is changed, then update changed at to be the current timestamp. So we could put something different here. We could put 3, although that's a problem because it's not a timestamp. But if we made this an int, I could do something ridiculous like this. And every time that comments a row is updated, it will change that to be the number 3. But there's no reason to do that whatsoever, so I won't. So if we run this, I called it comments 2, by the way. I'm not pointing that out because I think it's original, but just so that you're aware, it's a different table. If I now, let me just use the same comments that I've already run and just change it to be insert into comments 2. So here's the first one. And our next one will be just LOL, LOL, LOL. Okay, and now we do a select star from comments 2. You can see change that is filled in because we created them. And let's just do one more. This time will be I like cats and dogs, just to please everybody, unless you're a bird person, I guess, or you hate animals. So they're ordered by default because this is the order we added them in. There's no other way that they would be ordered. But let's try updating one. Okay, so let's update this gibberish here to say something else. It's been a while since we've done an update, but hopefully you remember. So we're going to want to update comments 2, set content equal to, and let's say this is not gibberish, or something like that. And then we need to specify where content is currently this mess of gibberish. Okay, so if I update that, notice what we had before, 20, 30, 18. The date's not going to change. 20, 30, 18. Now if I do a select star, it's changed to 203302. And so now if we order things by, what do we call it? Change dat, you'll see we now have a new order. And so that's really important to take note of, is that if you want to not only track when something was created, but when it was updated, you can use this setup here. So we have timestamp default now, on update. Oh, one thing I didn't talk about, current timestamp. You could also put now here. The reason I didn't is just to show you, you can also use current timestamp. It's just another shortcut. I prefer to use now just because it's, like I said a couple times, short, simple, easy to remember, but current timestamp does the exact same thing in this case. Okay, so this is something, a bit of a recipe that you'll probably return to. It's worth knowing. You'll see me use it as we go in this course and some of the other schemas that we create as things get more complex. It's important, it's useful to store that metadata about when things are created or when they're updated. Okay, we're done. Okay, so we're at the end of this section, and as always, it's your turn to put it into practice, as you can see by these giant letters. So we've got a couple of problems here that cover basically everything we talked about. Well, not everything, but all the big things we talked about in this section, all about data types. So strings, text data types, numeric data types, and then date and time information and ways of working with those dates with some of the more common date functions. So there's a couple of exercises here. Some of them involve writing code, some of them are fill in the blanks, and some of them are just, I don't know what you would call this, free response, like this one here. So let's get started, and then in the next video we'll have a solution. So this one, what's a good use case for char, or chair, or no, not chair, char, or car, that data type. So when would you use that instead of, or in lieu of, varchar? So you can use one of the things that we talked about, or come up with your own. You don't have to write it down. Just come up with something. Next up, fill in the blanks here. So we've got a table that I'm creating called inventory or inventories or whatever, some sort of something that we're storing, books or toys. We've got an item name. What data type should that be? There's not necessarily only one workable answer, but there's one better answer. Price. So what data type should price be? And not just the type of, or not just the name of the data type, but what are you going to put in those parentheses? And as a note, all of our prices are less than $1 million. Not equal to $1 million, just to be clear. They're less than 1 million. So how would we represent that with our data type? And then quantity. That's a number as well. What data type makes the most sense there? Okay, then moving on. What's the difference between date time and timestamp? There's not just one difference, but when would you use one versus the other? How are they different? We talked about it. We looked at the documentation for both of them. So hopefully it's not too hard. Next up, in Cloud9, print out the current time using MySQL. So just the time. Then the next question is to print out the current date, but not the time. So just the date. And then once you've done that, print out the current day of the week, the number of the day of the week. So if it's a Saturday, it should be 7. If it's a Friday, 6, and so on. So just print that out. And then do the same thing, print out the current day of the week. But this time it should be the name of the day of the week, like Monday or Tuesday. So the English name of the day of the week for today, the current, whenever you're running this, print out the day of the week. Next up, print out the current day and time using this format. So month / day / 4 digits for the year. And then once you've done that, we have another one. Print out the current day and time using this format, which I wasn't sure how to actually boil this down to a nice little formula like we have here. So I just gave you 2 examples. So we have the full month name, January or April. Then we have this, which there's a name for it. I think it's the anglicized, what is it? Anglicized digits or something. It's in the documentation, so we didn't cover this. You'll have to dig around to figure out how you format it this way. But with the day of the month, like 2 or 1, but instead of just the number, we want this anglicized version, so 2nd, 1st, 3rd, 10th, and so on. And then at, and then the time. And for the time, we just want hour, minutes. Okay. After you've done that, we have one final thing. Create a tweets table, and the tweets table should store the content of a tweet. So that's going to be text, and I believe, 140 characters, and then a username, and we don't need a character limit for that. Let's say 20 characters, but that's not that important. And then we also want to store the time the tweet was created. Okay, when you've done that, pat yourself on the back. Okay, so this is the solution video to our data types problem set. First one here. What's a good use case for char? So there's not a ton of times that I end up using them, but remember they are fixed length, so we have to specify exactly the length of the char that we want for that column. So we often will use it for text that we know 100% has a fixed length. So the one that I've used a couple of times is state abbreviations. If you're doing sex, like M or F, or perhaps you're working on a project where, let's say you're working with companies and you want an abbreviated name for every company that's only 5 characters or 4 characters long, then you could use char as well. Hopefully you came up with something better than me, something new and original. Next up, fill in the blanks of this schema. Okay, so there's a couple things to talk about. Item name is text. It's going to be something like, Cabbage Patch Doll or baseball hat. And that should be a varchar, most likely. I mean, you could get away with using a char, but there's no reason to do that because it's not fixed length. So it makes more sense to do varchar. And then quantity, I'll skip price for a moment. Quantity makes sense to be an integer. We are never going to have partial items in stock. We're not going to have 2.5 Cabbage Patch Dolls, hopefully, unless there was some sort of massacre with the Cabbage Patch Dolls and a chainsaw. We're hopefully only going to have whole numbers of them, so we'll use int. But price is a little trickier. And so I added this note. Price is always less than $1 million. Okay, but price is not usually or not exclusively a whole number. We want to allow for cents. So we're going to want to use a decimal. Now you could use a float or a double, but as we discussed, decimal is better for monetary stuff because it's more precise. You don't have to worry about losing precision as you get into longer numbers. Okay, so then the question is, what do we put here? It's not just decimal on its own, right? We don't just do this. We have 2 numbers we pass in. And those 2 numbers, if you can remember the names, I believe the first one is precision and the second one is scale. Don't quote me on that though. But basically it's a total number of digits followed by the number of digits after the decimal. So we can start with the number of digits after the decimal, which when you're working with price or monetary information, it's pretty much always 2. So then the question becomes, how many total digits do we need? And if I said it's always less than it's always less than 1 million, that means that our highest price we could have is 999,999.99. So if that's the maximum price, then all we need to do is count up the total number of digits. So that is 3, 6, 7, 8. And that's our answer. Decimal 8,2. Next up, what's the difference between date time and timestamp? So I have the documentation open for date time, and timestamp. And the first thing I'll say is that there's a couple of differences. There are a few technical differences as far as how they're stored and the ranges that they support. And then there's a big difference into how they're put into use most of the time. So both of them, let's start off, they both store date and time information. So they store the date and then the time. However, there's a big difference in the range that they support. So timestamps have a much smaller range, If you remember, we went over this. Where is that? Timestamp has a range from 1970 to 2038 versus date time goes from 1000, year 1000, up to year 9999. So that's one significant difference. The other is the size or the memory they take up. A date time is roughly twice as large as a timestamp, which brings us to the final difference, which is how they're actually put into practice. And typically, timestamps are used, at least in my experience, exclusively when we are trying to add metadata about when something is created or updated to a table. Otherwise, I use date time. Now, that doesn't mean that you can't use timestamp. If you wanted to use timestamp to store birthdays, you could, but you could run into problems if you have, people who are born before 1970. So again, the key differences really boil down to the ranges they support and then how much memory they take up. Okay, moving on. Print out the current time. Finally, some code. So to print out the current time, it's just a matter of cur time. And we need to select that. There we go, 16:08:13. Yours, of course, will differ, most likely. Print out the current date, but not the time. So that one, we want to do cur date. As you can see, April 22nd, 2017, still my birthday. Print out the current day of the week. Okay, so this one's a little bit different. There's a couple ways of achieving this. The first one is to use select day of week, and then we could either give it the date, cur date, or we could use now. So today is a Saturday, so it gives us 7. Just to show you, I can replace this with now, which is a date time, and I also get 7. But there's another way we could do this, which is to use date format. And if we go to the documentation here, and we find this date format, if we scroll down, somewhere on here is day of the week. Where is that? Here we go. Day of the week, %W, lowercase w. So we could use that, do select date format now, or cur date, comma, and the string we want is just %, lowercase w. And actually, I didn't know this until now. There is a difference. That's kind of fascinating. If we read this closely, it says day of the week, 0 is Sunday, and 6 is Saturday. So these are not equivalent, actually. Day of the week, Sunday is 1 rather than 0, and Saturday is 7. So I guess if we wanted these to be equivalent, we would need to do a +1 and shift everything by 1, or shift everything down 1 if we're using the previous. Interesting. No idea why that's the case, but it is what it is. So the next thing is to print out the current day of the week, but I want the day name, Monday, Tuesday, Wednesday, and so on. I wouldn't expect you to remember this, but there is a day name that we can use, like that, select day name, or we can do our format date, or date format. I always mix up the order there, but it's date_format for now. And then we just have to figure out how we get the day of the week name. So if we go to the docs, it's right above. Weekday name, Sunday to Saturday, %, W. So if we switch back, just change it to an uppercase W, now we get Saturday. Okay. Next up, print out the current date and time using this format. Month, / day, / year. Okay. So we'll need to use date format. And we can just use cur date, or we can use now. I like to use now typically, but we're not actually using the time information. So why don't we just use cur date in this case, just to show you we can. And then the way we want to format it, if we go to the docs, we want, first of all, was the month. So we want month numeric, which is %. Oh no, that's not what we want. What we want is down here, this month numeric, 0 to 12. So we get M, lowercase m, %, lowercase m, / and then we want day of the month numeric 00 to 31 because we want those 2 digits always. So that's lowercase d. So we have lowercase m / lowercase d, and then for year, we want 4 digits. So that's uppercase Y. So let's try that. Percent, lowercase m / percent, lowercase d / percent, uppercase Y. Oh, semicolon. There we go. And that works. Next up, print out the current day and time using this format. It's a bit different. I want the month name and then the anglicized day at, and then hours and minutes. So let's start off with what we know. We're going to need to use date format, and we need to use now because we need date and time rather than cur date, which gives us just the date. Then our format string, first thing we want is the month name, which is right, where are you? This is abbreviated month name. Here we go. Month name, uppercase M. So we want uppercase M space, and then the anglicized version of the day. And where is that? Here we go. Day of the month with English suffix. That's what I was trying to say. So it's uppercase D. Okay. Let's just see if that works to start. There we go. April 22nd. Followed by at. No years necessary. So at, and then hours and minutes. So again, hours. We have upper or lowercase h. If we want, I guess I didn't specify if we wanted 24-hour time or 12 hours, so either of these will work. I'm just going to do lowercase h, colon, and then for minutes, it's lowercase, well, let's see, I is going to give us, there we go, that will work, lowercase I. Okay, so lowercase h, colon, lowercase I. There we go, April 22nd at 4:15. Great. Now moving on to our final problem, create a tweets table that stores the tweet content, a username, and the time it was created. So the tweet itself can vary in length, so it should be a varchar, most likely. A username could vary in length as well. And then the time it's created could be a date time. It could just be a time if you wanted it to, but what makes the most sense, as we discussed already, is to use timestamp. And we want to set the default to be now. So let's try it. Let's hop over here. And the first thing we want is a create table tweets. And then we're going to have tweet content. So we could call that whatever we want. I'll just call it content. And that will be a varchar up to 140 characters. Then we have username, which will also be a varchar up to 20 characters. And then finally, we have created at or tweeted at or time or whatever you want to call it, which will be a timestamp. And then the important part is default now or default current timestamp, but I like to use now. So let's try it, see if it works. Make sure we have the right commas in place. Semicolon. And good thing we tried it. I'm missing parentheses around now. Let's add the semicolon in as well. Okay, make some space. Now we run it, and it appears to work. Let's just make sure by inserting one tweet. So we'll do content, username. Remember, we don't need to insert created at manually. And let's see, content will be, this is my first tweet, and username will be Colt's cat. Okay, let's do a select star from tweets. And you can see we have created that in there as a timestamp. Works perfectly. Just double check by inserting something else. Let's just change it slightly. This is my second tweet. Now if we select star, 2 different timestamps, just a couple seconds later. Okay, now the hardest part. Pat yourself on the back. You made it through. Siri, can you say hello?
Hello, it's me. I was wondering if after all these years you'd like to meet, to go over everything. They say that time's supposed to heal ya, but I ain't done much healing.
Okay, thank you, Siri. Can you just say hello, not sing it?
Hi, Colt wants me to say hello and welcome to the next section.
Thank you, Siri. So as Siri said, hi, welcome to the next section. This section is all about logical operators. So if you come from a programming language or have any programming experience, you have probably stumbled across logical operators. Things like logical and logical or. There's a bunch of others, but those are the primary two. If you have no idea what I'm talking about, don't panic. That's what this section is all about. So this will either serve as a review if you know how to program or if you know logical operators, and it will serve as a way to show you how they work in MySQL, or it will serve to both introduce them and to show you how they work in MySQL. Either way, they're really powerful. I'm not going to say they're important, they are important, but I'm just overusing that phrase in these videos. Everything's important here. But these allow us to string together different queries and make more complex selections. So if I were to give you a really contrived, idiotic example like cars, and I want to select all cars based off of a color, right now all we could do is select all cars that have a color of exactly blue, or a color that contains the word blue, like, I don't know, sky blue or seashore blue or something like that. That's fine. But what if you also wanted to select all cars that were blue or that were red? Again, I said contrived and silly, but the idea is we can string things together. So rather than having to do two queries, we could put them together. Or if we go to our books example, which by the way, we're about to finish with, this is the last of that section, last of our books data, we could make more complex selections like select all books that have a price below $20 and at the same time, we have 50 copies in stock. Or we could do something like select all books written by a certain author before the year 1990. So two different components, right? We could select all books before 1990, select all books written by a certain author, but put them together, we need to use a logical operator. All right, I'm rambling a little bit, I apologize. This section is on logical operators, lots of exercises, of course, like always. Hopefully they're enjoyable. If not, well, like I said, it is a course on databases. So I'm trying, I really am. Yeah. Okay, I'm going to stop.
Welcome back.
So in this section, we're going to focus on what are called logical operators. Actually, we're focusing on operators in general, and most of the ones we're going to work with are logical operators. That distinction doesn't really matter, though. I'm just going to call them all logical operators, and they allow us to add logic into our SQL statements. So up until this point, we've seen things like, which allows us to select things based off of text looking or containing certain strings, matching patterns. We've seen how to do things where we can check, select all books where the title is exactly Lincoln in the Bardo, or where release year is exactly 2013. But there's a whole slew of other things that we'd like to be able to select based off of, and that's what we're going to focus on in this section. So we're going to see how to do things like select all books not published in 2017. Right now, we don't have a way of doing that. Or what about select all birthdays between two different dates? So not just all birthdays that are exactly, April 22nd, 1990 or 1992 or whatever it is, but between those two dates. Or select all items, so this is some table I made up called items, all items that are in stock and priced below 1999. So that's two different things. We know how to select all items that are in stock, but there's a second component, which is not only do they need to be in stock, but they need to be priced below 1999. And right now, we don't know how to do that either. With that lengthy introduction out of the way, let's take a look at some of our first ones. So the actual first one we're going to look at is called not equal. And it looks like this: exclamation point and an equal sign. So we've seen how to do things using equal sign, right? We've done, select, let's do title, comma, released year from books where, and let's do released year. So where released year is exactly 2017. So we've seen how to do this. with the equal sign. We've been doing it all the time. However, what if I want to do the opposite? I want all books that were released in any year excluding 2017. So what we want to do is basically replace that equal sign with a not equals. So we could do this. Select title from books where year is not equal to 2017. If you're familiar with any programming languages, you've probably come across this not equals. It's a pretty universal way of writing not equals. So let's give it a shot. Recall this and just replace it with not equals. And now you can hopefully see that we get everything back except for Lincoln and the Bardo. And of course, if there was more than one book released in 2017, then we would get any book back or all books back except those books from 2017. So we can see that it's gone. We could do the same thing, but instead of working with release year, what if we do it with author? So let me just start over here. Let's select title and author last name from books, and we'll start just with all of them. And then let's select where author last name is exactly equal to Harris. So we have those two Harrises. Where author L name equals Harris, just like that. And we get those two. And by just flipping the switch here, that exclamation point, we now get everything except those two. Okay, so hopefully you get the point by now. Not equals works like you would expect. If you're not familiar with the exclamation point, it might take a little bit of getting used to, but otherwise, it's pretty straightforward. It's the opposite of equals. Awesome. So that's the first one that we're taking a look at, but we have quite a few more. Next up, we're going to talk about something very similar, which is not like. Okay, so we saw not equals, which is the opposite of the equal sign. Now we're going to look at not like. And as you probably guessed, not like is the opposite of like. So just to review, we haven't used like all that much, but it is a pretty common and important one. It allows us to match patterns in strings usually. So we can do things like select, let's do all titles, and we'll just do title from books where title like, and we can do things like, we'll start off, how about all books that start with the letter W, just like that. And if we just do W on its own, remember that doesn't really give us anything unless it's an exact match of the letter W, but we use the percent sign there as a placeholder. And now this says all books that start with the letter W and anything afterwards, or we could expand that to be any title that has the letter W. Okay, so that's it for review. That's how like works. We match these patterns, and anything that matches this pattern, where these are placeholders, the percent signs mean anything goes there. Anything that matches this will be returned. So all of these contain a W somewhere. All right, so that brings us to not like, which, as you have probably surmised by now, it will do the opposite. So here's an example. Select all books with titles that don't start with the letter W. So rather than the exclamation point equals, like we had for not equals, we just use the word not space like. And then in this case, W percent sign means something that has a W and then anything after that. And then we're negating that with not. So this in effect says select all the book titles that don't start with the letter W. So if we go back, recall this, which gives us these. Well, actually, let me get rid of the percent sign at the beginning. These are the three books that start with a W. What we talk about when we talk about love, where I'm calling from, and white noise. And if we go and just add NOT, now we get all book titles excluding these three. All right, so that's it for not like. Hopefully you liked that rather than not liked it, I guess. All right, well, let's just move on. So next up, we're moving on to the next subset of logical operators. There's a group that fits together nicely, which you're probably familiar with just from middle school or early school years. And those are the greater than, greater than and equal to, greater than or equal to, less than, and less than or equal to. So 4 operators, very similar and pretty useful. So this is the greater than operator in MySQL. It's pretty standard. What is this called? The alligator bracket? I don't know what to call this, honestly. I just call it the greater than bracket. It's pretty universal across programming, and it allows us to do things like select all the books released after a certain year. So select all books where release year is greater than the year 2000. And typically we're working with numbers. I'll talk about strings in a little bit, but typically we're working with numbers. So an example, earlier today, I was looking on Airbnb to book an Airbnb, and they have a filter that allows you to set a minimum price or a maximum price. So if I wanted to, I could have gone in and said, I only want to book Airbnbs that have a price greater than $50 a night or something, to filter out the $20 a night couches in some person's living room. So that's powered behind the scenes, most likely by a greater than sign. So now let's give it a shot on our own. If we hop over here, let's start by just selecting all titles and release year from books. And let's just order by release year. Just ordering it will let us see, when we remove things, it will make it clearer rather than having them just be jumbled. Okay, so we've got 1945 up to 2017. Now, if I want to go ahead and do what I showed you, which is select all the books released in the 2000s or after the year 2000, all I need to do is add in where release year is greater than 2000, just like that. And if we look, we lost everything from here on back. So from Cannery Row to The Amazing Adventures of Cavalier and Clay. Important to note that 2000 is not included, which we'll get to in just a moment, but everything greater than 2000 is. So that gives us all of these books from American Gods down to Lincoln and the Bardo. As you can see, here we go. So that brings us to greater than or equal to, which works exactly the same way, except you add in this equal sign afterwards, which makes it, rather than greater than, it makes it greater than or equal to, which means that it's inclusive. So if I just change that and do where release year, rather than greater than, is greater than or equal to 2000, now it includes the year 2000. Let's do one more quick example. Let's do a select title and stock quantity from books. And let's say that we're going to do a sale because we have some excess stock in some of our books. Any book that we have more than 100, including 100, let's say, so 100 or more copies in stock, we want to select, and we're going to discount them. So how do we select those? Well, it's pretty straightforward. We're just going to select title and stock quantity from books where stock quantity is greater than or equal to 100. And there we go. These are the books that we're going to discount. All right. Okay, so there's one other small tangent I want to talk about. It's a bit of a diversion away from the tables and books that we've been working with. This has nothing to do with any particular data. But if you try running something like this, select 99 greater than 1. What do you expect? Well, go ahead and try it if you'd like. I'll go and type it over here. Select 99 greater than 1. If we hit enter, we get the number 1 back. All right, so if you're familiar with other programming languages, you've probably come across Boolean values, true or false values. And that's what MySQL is replicating here. So the way that it works in Boolean logic is it actually works with the numbers 0 and 1. So we know that 99 is greater than 1. That's true. And so we get 1, which is equivalent to true. Basically, this evaluates to 1, which you can think of as evaluating to true. So if that's confusing you, let's try something. Let's change 99 greater than 1 to is 99 greater than 5, 6, 7. Oh, I just lost it. Here we go. We know that that's false. And you can see we get 0. So the reason that I'm showing this to you, well, there's two reasons. One is that it will help us going forward with some of the other things I'm going to show you when we can start chaining things together, you'll be able to evaluate them and kind of do some exercises on your own first. But the other thing, and the more important reason, is that this is what's happening behind the scenes. When we have something like this right here, where stock quantity is greater than or equal to 100, you can almost think of it as MySQL going through every stock quantity and plugging it in here and trying, okay, is 100 greater than or equal to 100? 1, yes. Okay, so keep that one. Is 23 greater than or equal to 100? 0, no, false. So get rid of that one. And it does that, going down the line. That's kind of the humanized version, if you will. But it's evaluating to these numbers, but those numbers are just bits in memory. But the concept is the same. So if you'd like, let's wrap this up with just a really simple exercise. I'm going to type up a few things, and I'd like for you to evaluate them yourselves. Okay, so I typed up a couple of examples here, and I'd like for you to just either mentally try these or actually try them yourselves. And remember, you'll need to actually run select, and you'll need a semicolon. But what's the result that you expect? And there are a couple of straightforward ones, and then I threw in 2 string ones at the end, basically to give myself a talking point at the end. I want to talk about why this happens and if you should care. So go ahead. I'll throw up a thing on the screen that says you should do it. And then in like 2 seconds, I'll be back. All right, I'm back. So first one, 100 greater than 5. Is that true? Well, yes, I believe that to be true. Just to double check, it gives us 1. That means we're in the clear. Negative 15 greater than 15. Is that true? Well, no, I don't think so. And we get 0. All right. 9 greater than negative 10. That seems like it should be true, and it is. What about 1 greater than 1? Well, I don't think 1 is greater than 1, so it's false. However, if there was the equal sign, of course, it would be true. All right. Now, these two. String comparisons with greater than, less than is notorious in all languages for 1, being annoying and confusing, and 2, differing radically between languages. So the advice that I would give to anyone is to just avoid ever having to do anything like this. There are ways around it, but I just wanted to show you what happens. So what do you think? Is the lowercase a, it comes before b, so is it greater than or less than b? And in some languages, it is greater than, in others, it's less than. In MySQL's case, MySQL, if we hit enter, we can see that A is not greater than B, meaning that it's less than B. Although technically that statement is logically wrong because it could be equal to B, but as you can see, if I add that equal sign, it's still false. So we know definitely A is less than B. Okay, so that brings us to our last one, which is a bit tricky. Uppercase A greater than lowercase a. And if we run that with a semicolon, you'll see that it's false. So uppercase A is not greater than lowercase a. So then does that mean that it's lower? Does uppercase A come before lowercase a? And the answer is actually, if we change this just slightly to be greater than or equal to, you'll see now it's true. So that tells us uppercase A is equivalent to lowercase a in MySQL's eyes. And we've seen that before. When we do something like, well, let me just type it again. Select author, lname, where author lname equals, if we do eggers like this, and of course I add in the all-important table name from books. So if I do this, and let's also do title just to make it easier to see what's going on, it matches just fine. But I can also do this with lowercase e, and it works just the same. Or I can do eggers like that with 2 uppercase g's. So the way that string comparisons work in MySQL is quite odd. And if you're familiar with other languages, it's very different from pretty much every language I've worked with. So just something worth noting, that case doesn't actually matter. All right, so now we're talking about less than. We just talked about greater than and greater than or equal to. So this one should be much shorter. In fact, the total time that it will take will be less than the previous video. Yeah. So it works the same way, although it does the opposite. If you're familiar, again, it's just the less than bracket, the angle bracket, I think is what they're called. I just remembered that. So shift, and then on most keyboards, it's a comma. So we can do things like this. So rather than selecting all books released after 2000, we just switch it to the less than sign, and I'll select star from books where released year is anything below the number 2000. So if we try that, select title and released year from books. If we do all of them, and let's do our order by again, released year, just to make it easier to see where we have missing gaps. Okay, so we want all of these to disappear, or excuse me, we want all of these to disappear, and we only want to select these 5. All we need to do is add in our where released year is less than 2000. And there we go. Okay, so that's pretty much all I'll say about it for now. Along with that, of course, we have less than or equal to, which works the same way that greater than, well, it doesn't work the same way. It works in the same way that greater than or equal to does. So if I wanted to include the year 2000 for whatever reason, I just need that equal sign after the less than sign. And now we get the same 5 books plus the one that was written in 2000, Amazing Adventures of Cavalier and Clay. That's pretty much it. I will throw up a few exercises here if you want to try evaluating them. And then we're moving on to some more interesting and complex operators. All right, so I'm back here. I typed up a couple of quick exercises. Go ahead, try these out. I'll throw up that same graphic again, and I'll be back in 1 second. Okay, I'm back here. So let's go through these quickly. The first one is 3 less than negative 10. Well, I don't think so, but let's verify. You can see 0 meaning false. It's not. Is negative 10 less than negative 9? Yes, it is. It's lower than negative 9. Is 42 less than or equal to 42? Oh, need to add a space there. And as you would expect, we get yes, we get 1 true, because 42 is equal to 42. And now on to the odd string ones. Is the letter H, lowercase, less than the letter P, also lowercase? And if you remember to the last video how this works, H comes before P, and they're both lowercase, so yes, this should be true. And it is. Okay, so this final one is uppercase Q less than or equal to lowercase q. Well, this should be reviewed from the last video, because remember that case doesn't matter. So we see that yes, indeed, it is true. Uppercase Q is less than or equal to lowercase q. And if we get rid of the equal to, this is basically a duplicate of what we just did in the last video, but I just want to hit this home, that it is not lower, it's not greater than, they are equivalent. Well, that's a minus sign. There we go. They're equivalent, as you can see. We get true, or 1. Okay, next up, moving on to much more exciting, much bigger and important logical operators. So in the last video at the end, I mentioned that we're about to move on to bigger and better operators. And this is the first of those. It's called logical AND. You'll also see it as just 2 ampersands. So what it does, it's sort of a step up in operators. It allows us to actually chain together multiple pieces of logical information, multiple operators together, and basically it necessitates that all things are true, all conditions are true. Now that sounds like gibberish, so let's put it in practice. Let's see what I mean. So here's an example. Let's say I wanted to do something like this. Select books written by Dave Eggers that are also published after the year 2010. So individually, these are each straightforward tasks. I color-coded them to show you. Select books written by Dave Eggers. We know how to do that. We also know how to do select all books published after the year 2010 using greater than, what we just saw. However, to put these together, we need to use logical AND. So here's the first part. Select books written by Dave Eggers. It would look like this. Select star from books where author lname equals Eggers. And then to select books published after the year 2010 would look like this. select star from books where release year is greater than 2010. So to put them together, we use and. Okay, so as I mentioned, we can either use the word or the text and or two ampersands. And it looks like this. Select star from books where author L name equals Eggers and release year is greater than 2010. And that's it. So basically we just take the two where clauses and shove them together with the word and. And what this means is that both parts have to be true in order for it to be selected. So it will check, is this author's last name Eggers? If it is, then it will move on and say, okay, and was it released after 2010? If it wasn't, then it discards it and it doesn't select it. However, if both parts are true, then we see the results. So let's try it. Okay, so let's start off by selecting title, author L name, and release year. And I'm just working in this document. I'm just going to copy and paste in, but I'm just putting a record of it here to make it easier for me to edit as I go through. So select title, author L name, and release year from books where, and we're just checking where author last name equals Eggers, just like that, with our semicolon. And you can see we have these three: hologram for the king, the circle, and my favorite, heartbreaking work of staggering genius. And then we have release year. So for some reason, someone comes into our bookstore and says, I really like Dave Eggers, but I only like his later stuff, which I would disagree with. I think his earlier stuff is better. But let's say someone says that. Well, then we would do something like select, and I'll actually just copy this and change the where clause to where release year is greater than 2010, which we already know how to do. This should be review. Now this gives us all books released after 2010. And then to combine them is where we use logical and. And release year greater than 2010. Okay, so let's check that it works. You can see we only get two results because both of these things have to match. So author has to be exactly Eggers, case insensitive, and release year has to be greater than the year 2010. And just to show you, we can replace this with double ampersands, and it works the exact same way. There we go. Okay, so that's the basics of and. We'll use it all the time. It's important when it's anytime you need to chain together things, if you're trying to search based off of two criteria. So a common example might be something like select star from products. Let's say we work in a toy store where brand equals Lego. But when you're on a store, online store, often there's like an option that will say, show out of stock items or don't show out of stock items. So we could do something behind the scenes like where brand is Lego and in stock equals true. That way we wouldn't be showing the customer any Lego products that are also out of stock, which is frustrating when you see that. So that's a pretty common use case is when you're working with a value, a Boolean yes or no value like in stock or is active user or something like that. Okay, so the last thing that I'll address here is if we go back to this sort of problem set things like 1 less than 5, but rather than just doing one on their own, I'm going to give you a couple here where we're going to chain them together with and I'll give you a first example here. So 1 greater than 5 and 7 equal to 9. So what does this whole thing evaluate to? Remember, both sides have to be true. So let's take either side. We'll take this one. Is 1 less than 5? Yes, that is true. Is 7 equal to 9? No, that's false. And that immediately nullifies or falsifies, the entire thing. Both sides have to be true. Just to double check, let's give it a shot. Select. And you can see 0, false. Okay, so just like before, I'm going to take a moment, fill out a couple of problems, and hopefully you'll stick around and give them a shot. All right, I'm back. So I have 3 simple problems, hopefully simple, that I typed out. Go ahead, give them a shot, and I'll be back. All right, what do you know? I'm back. So let's go over these quickly. The first one, remember, both sides have to be true. So start with the first one. -10 greater than -20. Is that true? Yes, it's larger than -20. How about this? Is 0 less than or equal to 0? Yes, because 0 is equal to 0. Therefore, we have true and true. So this whole thing is true. Let's try it out. Yep, we get 1. Okay, moving on. We have, is -40 less than or equal to 0? And yes, I know I had a negative sign here. I apologize. That was an accident. That's wrong. So hopefully you didn't spend too much time panicking about that. Is -40 less than or equal to 0? That's true. It's smaller than 0. And I used the English version, AND. 10 greater than 40. Well, that's actually false, which makes the whole thing false, unfortunately. So let's try it. And we get 0, which means false. Finally, is 54 less than or equal to 54? That's true. 54 is equal to 54. And is A equal to A? Uppercase. Lowercase a equal to uppercase. By now you should remember they are equivalent. So there's true on both sides. And we get true. All right. So the last thing I want to highlight about and is that we're not limited to just 2 components like we saw here. You know, where author LNAME is Eggers and release year is greater than 2010, we could do 3. We could do 20 if we wanted to. There's probably an upper limit at some point, but typically, if you're working with anything more than 3, there are other ways of doing it, or you may need to change your table structure, which we'll get to once we talk about tables in more depth, and we talk about joins in particular. But in this case, I could do something like this, where author last name is Eggers, and release year is 2010, and title contains the word novel. Don't ask why, but let's say we have a needy customer who wants a Dave Eggers book, only likes his later work, and wants it to be a novel. And the way that she knows or he knows it's a novel is that it contains the word novel in the title. Well, if we go back to what we had here, let's just copy this and duplicate it and add another condition. And I'll do them on separate lines now. So I'll do ampersands for that one, but then I'll do AND for the last condition, which is title, like, and all that we want is % novel, %, semicolon. So let's try that. And there we go. We get hologram for the king, a novel, because, okay, first part, author name is Eggers, release year is greater than 2010, 2012 is, and title contains the word novel, so all 3 are met. So this is the only result we get. So that was just to show you that it's not limited to 2 conditions. Next up, we're going to talk about another kind of sister or brother operator, which is logical OR. All right, so we're moving on to logical OR, which, as I just mentioned, is like the brother or sister to logical AND. And if you've worked with any programming language, you're most likely familiar with and or, logical and logical OR. So logical OR you can either write out as OR, or just like we could write AND for and, or we can use these 2 pipe symbols. So these are not uppercase I's or L's or 1s. They are the pipe character, which is usually located above the right return or enter key. You have to hit shift most often to hit it. It's 2 of them together, just like it was 2 ampersands for and. It's just symbols. It's pretty standardized or very standardized across all programming languages that I've worked in. Ampersands for and, pipes for or. But you can also use the phonetic or the spelled out version OR. So before we dive into exactly how it works, let's try something. So we had this in the last video. This selects all books written by Dave Eggers, released after the year 2010. But what if we just change the ampersands to the OR pipes? What do you think will happen, first of all? So I'm just going to copy this so we don't have to type this all again. And just change the ampersands here to OR. And I'll hit return so it's clearer what's happening. So if we read this, if you just say the word or here, it makes a bit more sense. Select title and author name and released year from books where author name is Eggers or released year is greater than 2010. So if we run it, what we'll get is all books written by Dave Eggers and all books where release year is greater than 2010. So rather than both sides of this having to be true, just if either side is true, we'll get the data. So we get all the books by Eggers, including this one, A Heartbreaking Work of Staggering Genius, which came before 2010. But then we move on to the second part, which MySQL selected all books that were released after 2010, regardless of the author name. So it's a way for us to specify two things, either of which we want to be true, or both. So in the case of A Hologram for the King, it is both written by Dave Eggers and it was released after 2010. Or same thing with The Circle here. But 10% Happier, for instance, was only this part was true. Released year is greater than 2010 because author L name is Harris, or Saunders in this case, or Gaiman. Okay, so again, that symbol right there, I forgot I made this nice little slide, this animation. That change of symbol is very, very important. It changes the meaning entirely from the statement. So if we have two conditions with an ampersand between them, or three, or any number of conditions with ampersands, it means that both sides must be true in order for the whole thing to be true, as we've seen already. However, with the or operator, it means only one side must be true for the whole thing to be true, or both sides can be true as well. And I know that's a bit odd to talk about in this way without actual examples. So if we hop over again, I'm going to do the same thing I've been doing the last couple of videos. I'm going to type up a few example exercises, and then we'll go over solutions. Okay, so I'm back here. I've got just three this time, that I'll use logical OR. So try them out, and then I'll be right back with a solution. And I'm back already. Okay, so first one here, 40 less than or equal to 100. Well, that part's true. 40 is less than 100. So it doesn't matter what's over here. This whole thing is true because we only need 1/2 to be true. It happens that -2 is not greater than 0, but that's irrelevant because the left side is true. Moving on to this one, 10 greater than 5, is that true? Yes. So it doesn't matter what's on the right side, but that happens to also be true, so the whole thing is true. So we get 1. And this last one, bit of a curveball, is the letter A equal to the number 5? Well, that's not true. However, this side says 3,000 is greater than 2,000. That is true, so the whole thing is true. As we can see, we get 1 for true. Okay, last thing before I forget, just like with AND, we can chain OR together as many times as we want, so it doesn't have to be something like this. So if I go back to this example, select title, author, L name, release year from books, where author name is Eggers or release year is greater than 2010. So let's try adding an OR here, and I'll spell it out this time. And let's say not only do we care, or do we want to select things written by Eggers or release year greater than 2010, we'll also add another OR, which is stock quantity is greater than 100. So books that we have a lot of stock in as well. And let's also print stock quantity, just like that. Let's copy this whole thing, paste it, semicolon. And if we look, see it makes a slight difference because we also get this David Foster Wallace story collection in here, which was written in 2004, which normally wouldn't make the cut with our previous version, but because we added stock quantity greater than 100, it's in here because stock quantity is greater than 172. So for some of these, for instance, A Hologram for the King, all 3 parts are true. It's written by Eggers, it's released after 2010, and it has more than 100 copies in stock. But then, like for David Foster Wallace and Oblivion, only one part is true, the last part. So it just goes to show you that only one component, even if we have 3 different conditions, only one part has to be true for the entire thing to be true and for it to be selected and spit back to us. Okay, so that's logical OR. One thing that I will point out that I know you're probably dying to get on with this video, but you can combine OR and we'll see how to do that in a little bit. So moving right along, our next operator we'll take a look at is called between. And between is pretty straightforward. It allows us to select things based off of two values, an upper and lower range. So I can say I want to find, all people who have a birthday between April 20th of 2017 and April 22nd of 2017. Or I want to find all books, that have page counts between 100 and 500 pages. So we actually can do this already using what you know. So before I show you between, how can we accomplish the same thing using the tools that we already have, things that we learned in this section already? Because if you take a moment to think about what being between two values actually means, it's really just a combination of greater than and less than. So how do we combine two different conditions? Well, logical and. So let's try an example again. Just to reiterate, if I wasn't clear, we're doing it without the new between operator. We haven't seen that yet. We're doing it the longer way, if you will. So select all books published between the years 2004 and 2015. And that includes 2004 and 2015, just to be clear. Okay, so to do that, we use logical and to join together two different conditions, two components. So select title and release year, blah, 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 that doesn't matter, from books where release year is greater than or equal to 2004 and release year is less than or equal to 2015. So both parts of that have to be true, meaning that whatever the book is that's selected, or all of the books that are selected, are somewhere between 2004, including 2004, and 2015, including 2015. So I won't make you watch me type this whole thing. I'm just going to paste it over here. But let's start off by just doing select title and release year from books. And just check, we know this, but just to verify that there are things outside that range. And now, if we paste in using the ampersand, and operator, which of course could also be written this way, if I could type correctly, you'll see that we get things that are between 2004 and 2015, and we know that it's inclusive, as you can see, because 2004 is here. And if we hadn't included that equal sign, then it would not be there. Okay, so really what I'm trying to show you is that you don't need a fancy between operator to accomplish this. You can just do it using good old-fashioned logic, using greater than and less than and a logical and. However, there is an operator between that will make it easier. So it looks like this. The syntax is between and then some value and some other value. This and here, I get it. It could be confusing when we also have this and this one, but they are different. So this and is paired with between always. So here's an example. Select title and release year again from books where release year between 2004 and 2015. So this does the exact same thing as this right here, but we don't have to use the greater than equal to, less than equal to. We don't have to write release year twice. All we have to do is say where release year between 2004 and 2015. And in my opinion, this is much easier to read, much easier to remember if you're trying to do this. Between is a pretty straightforward thing to recall. It does what it sounds like. So let's try it out. Just copy it. I'll bring it here so we have a record in the notes. And then I'll just paste it in. Select title, release year from books, where release year between 2004 and 2015. And as you can see, we get the same results that we did when we used this version. It's just a little shorter and cleaner and easier to understand, in my opinion. And again, it is inclusive. We have 2004 there. And one thing to keep in mind is that there may be times where you don't want it to be inclusive, and there's not an easy way just to do that. Well, there is an easy way, but it basically just means change this number. If you want it to be 2005 to 2014, you could do that. But there's no easy way to, do between non-inclusive like here, where we can just eliminate the equal sign. Okay. So one other thing is that not between is also a thing. And it's pretty straightforward. Basically, it does the opposite of between. So we could say, I want all the books that have a page length that is not between 100 and 500. And that gives us everything less than 100 and everything greater than 500. So here's our same example. If we do select title and release year from books where release year is not between, so all that changes is we add an OT before, not between 2004 and 2015. It takes that range from 2004 and 2015 and does everything outside of that. So I'll just paste it here and then paste it in again. And now you can see, let's do an order by. Now you can see we have everything up until 2004 and then everything after 2015, but nothing from 2004 up to 2015. They're gone. These are just the leftovers. Okay, so that's pretty much it for the basics of between and not between. So before I let you go, there's one small side note I just want to bring up. It's not crucial to understanding between, but it's just something that the documentation mentions, so I figured I should also mention it. If we go to the docs for between, there is this note at the end. For best results when using between with date or time values, use cast to explicitly convert the values to the desired data type. So we haven't seen this cast, I'll talk about it in a moment, but what it lets us do is convert from one data type to another, from a date to a date time, for instance, or from a string, a varchar, to a date. For example, if you compare date time to two date values, so we're trying to say if some date time is between two different dates, it's best to convert the date values to also be date times, just so that you're working with the same kind of consistent data type. If you use a string constant, such as 2001-1-1, in a comparison to a date, it's better to cast the string to a date. So let's just take a look at how cast works first. And it's pretty simple. So let's take something like this, 2017-05-02. That right there is not technically a date, right? That's not considered a date data type. It's just text, even though it looks like a date, and it can be treated like one. MySQL is smart enough to figure that out if we pass it into a date function, like days or months or format date, but it's not actually a date. But if we wanted to make it an actual date time, we can cast it. And this will work its magic. Now just casting it like this won't do anything. I have to say what to cast it as. So let's cast it as a date time. And we won't see anything unless we have select here. So what this will do is it takes the first thing, whatever it is, and it tries to convert it to a date time. So if there's just, the number 99 or something, that will cause a problem. But in this case, this is easily castable to a date time. But you might be wondering, okay, the date part is easy to cast. What about the time part? Well, it just picks 0000 for you. So it's now considered a date time. So basically what the documentation is saying is if you're working with dates and you're trying to compare them, and you're working with between, for example, it's best to use cast to make sure that all the data types are the same. Now, this is kind of confusing. It will work most of the time just fine if you don't, because MySQL is smart enough to figure out what you want, but it can cause problems. So it's just best to do that. So I'm going to switch over to that testing database I made with this wonderful name, use testing DB. And the only reason I'm doing this is so that we have some date data. So we have a people table, and they have a birth date, birth time, and birth date time. So let's say I want to select people who have a birth date time between two dates. Let's say between 1980, let's do January 1st, 1980, and January 1st, 2000. So I'm going to write it up here, but the basics would be select name, and we'll do birth date time from people where birth date time between. And if we just do this, 1980 01-01 and 2000-0101. If I just do this on its own, first thing that we're doing here is these are strings, right? These aren't even dates technically. It's text. But if I do this, it still works. And that's what I was mentioning. That's kind of weird, is that it works fine enough because MySQL is smart enough. It figures out, okay, this is the date time. We're trying to compare it, see if it's between these two things. What are these? Well, they're not date times, but we still can handle it. There's some contingency code written back in MySQL to make that work. But it's much smarter and more fail-proof to do this. Cast this as date time. And I'll do this second part on a new line. And cast this as a date time as well. So that we're working with date time, date time, date time. And you won't see a difference here, but you can rest easier, can sleep better at night, knowing that you're doing the right thing. Okay, we're done. Alrighty, so next up, we're talking about a new operator called in, I-N. And what it does is it allows us to provide a set of values, 2, 3, 10, 50 different values, and then check if a given column is in that set. So basically, let me put that in an easier to understand way. Say we wanted to do this. I want to select all the books written by Carver, Raymond Carver, or Lahiri, Jhumpa Lahiri, or Smith, in our case, Patty Smith. So we know how to do that right now. I mean, if you listen to how I just said that with these ors, we would say select all books written by Carver, or by Lahiri, or by Smith. It would look something like this. Select title and author last name from books where author last name is equal to Carver, or author last name is equal to Lahiri, or author last name is equal to Smith. So this works. I'll come on over to Cloud9. First thing I'll need to do is switch databases. I'm using the new testing DB, so I'm going to use Bookshop again. Okay, so now I'm going to use this. Select title and author name from these three, or from where author is one of these three. If I paste that in, you can see we get all the books by Lahiri, Smith, and Carver. Perfect. However, as you probably guessed, there's a better way to do it. In will make it much easier and much shorter. So it looks like this. Select title and author from the first book, or from books, same thing, where author last name is in, and then in parentheses, we pass in a comma separated list of values. So if author name matches anything in here, it will be, the row will be selected. So it's really straightforward, very simple to use. It basically goes from this, multiple lines, and look at how much repetition we have. Author name equals, or author name equals, or author name equals, and condenses it down to this. So let's try it out. I'll paste this down here so you can just compare. If we paste it in, you can see it does the exact same thing. And the other good thing is that, as we add in more conditions, or more authors in our case, this continues to get much longer every time. This is really just a very simple change if we also want to add in another author. Very easy. So it's pretty useful. You're not limited just to working with text. So I'll just duplicate this just to show you. We could do select title and released year, where released year is in, let's say 2017 or 1985, just like that. And if we paste that in, we get these two books. All right, so that was just to show you it doesn't have to be strings. You can work with numbers as well. As you probably guessed, maybe you didn't, I don't know, but there's also a not in, and it works just like not between worked compared to between. It will do the opposite of in. So let's say, this is a really dumb hypothetical, but let's say I'm really superstitious and I have a problem with even numbers. And I go into the bookstore and I tell the clerk this, even though I promise I'm not superstitious and I don't have a problem with even numbers. If anything, I really like even numbers, if you can. But I go into the store and I say, I want to get all books that were not published in even number years, 2000 until 2016. So I want to exclude 2000, 2002, 2004, and so on. Well, I could do this, which is kind of a nightmare, where I'm basically using logical ands and not equals. So remember, I'm going to have to go back a few slides here. When we were doing this version here, before we talked about in, I was doing equals and or. So author L-name equals Carver or author L-name equals Lahiri. But when we negate it and I want to do the opposite, I need to negate the equals with a not equals, and I flip the or to an and. Which, when I say it that way, I realize it may sound a bit more intimidating than it is. Basically, logically, if we step through this, what I'm saying is I want to select all the books where release year is not 2000, and it's not 2002, and it's not 2004, and it's not any of these. So anything other than these values. And or wouldn't work here. It has to be and. Okay, but the point is that this is a mess. It's obnoxious. It's gigantic. If I do copy it over and I try running it, you'll see we get all books from odd number years. But there's a better way. We can use not in, which works just like you'd expect. Rather than saying in, we just say not in, and we provide that list, that set of values. And in this case, I've just passed them all in. Notice the difference there, massive difference. And if we run this, whoops, we get the exact same result, but much, much shorter and much easier to add onto or change. Now, some of you might be thinking, well, this still seems really silly. There's a couple things that we can change. One is that I only want books released after 2000. So right now, I'm basically saying I don't want any even years in the 2000s, but we're still getting even years, like 96. Is there any others? I guess it's just 96. So what I could do is I say that I only want books released after 2000, and it would just look like this. So the only reason I'm showing you this is so that you can see how to use logical and in conjunction with something like not in. So all that we're doing here is selecting books where the release after the year 2000, including 2000, greater than or equal to 2000. So that's going to narrow it down significantly. And then within that subset, we only want ones that were released in years that are not contained here. So the odd numbers, the odd 2000s, 2001, 2003, and so on. So as far as why you would do this, let's say that I have tastes in literature and I only want recent books from odd years. And let's do an order by. There we go. So we get 2001 all the way up to 2017. All the modern books with odd years. But there's still something more. And it doesn't require us to use in or not in. Because if you look at this, this is pretty repetitive. Well, repetitive is the wrong word. It's long, and there's a pattern here, right? So there has to be a better way to express this. And what I'm going to show you here has nothing to do with in or not in, so it's a bit of a tangent, but I feel that it's worth talking about. If you're familiar with programming, the solution here is to use an operator called modulo. And basically, this is also known as the remainder operator. What it will allow us to do is test if something is even. So how do we know if something is even in general? Well, it's divisible evenly by 2, right? If we can divide 2 into a number and there's no remainder, that means that it's even. So 4 divided by 2 is 2, and it's just a whole number, so it's perfect. But 3, or let's say 7 divided by 2, is not a clean, even division. So that means that it's not an even number. So there's a way to do that. It looks like this. So the percent sign is known, as I said, as modulo, the remainder operator. So if we just focus on that part, this is saying release year divided by 2, the remainder is not equal to 0. So if we plug in 2000 right here, 2000 divided by 2, the remainder of that is 0. But if we plug in 2001, the remainder is not 0, the remainder is 1, meaning that it's odd. So again, this is above and beyond what you need to know, but I just figured it would come up in the comments if someone saw this gigantic mess here. Someone would probably say there's a better way, and they're right. It just happens to not use in or not in, which is the whole point of this video, but I figured it was still worth talking about. So what we're doing, selecting the same stuff, title, release year from books. First thing is the same, only selecting books that are released after the year 2000 or including the year 2000. And then they also have to be odd years. So released year mod 2 is not equal to 0. 2 does not divide cleanly. And I'll paste that in just so we have a record. Run it. And you can see now I only get the same exact result, right? Let me order it so that we can compare. No, I have a typo. Okay, so we get the exact same results that we got earlier, but we didn't have to write all these years out explicitly. And the other advantage is this solution works when we're in 2018 and 2020 and whatever other even numbers we have. As long as they are even and are greater than 2000, it will be filtered out. So this is, in my opinion, a better solution. It grows and it expands more. The other thing, there's a bit of a performance difference. It's not major, but when we look at this, basically, if we're pretending, let's personify or anthropomorphize MySQL, and it's taking a year like 2013. When we have not in, it's going to try, is 2013 equal to 2000? No. Is it equal to 2002? No. Is it equal to 2004? And it's going to keep going down. It has to try every option. There's no way to know unless it actually matches it or tries to match it against every year we have in this set. So that could potentially take a lot more time than doing a single mathematical operation like we have here. We're just checking, is the release year mod 2 not equal to 0? And it's really not a big difference, but it's just something that's nice to be aware of. Okay, so big tangent here. This video was really about in and not in. So just to go back to there, very useful. Allow us to pass in a set of numbers or strings or values, dates, whatever it is, which then our rows are checked against to see if they are either contained or not contained, depending on if we're using in or not in. All right. Okay. So we now have one more video, one new bit of information before we move on to the exercises and wrap up this section and go on to join tables. Very important, big topic. But before we do that, we have this video, which is on something called case statements. This is a pretty, exciting is relative. This is very different than things that we've seen in this section. It has to do with logic, but it's kind of on a bigger scale. It allows us to make decisions. So if you're familiar with programming languages, that's something I've been saying a lot in this section, but if you are, you've probably come across case statements or conditional statements, which allow you to add logic in to do things like conditionally print something out. It's a very simple example, but if a number is greater than 5, print one thing. Otherwise, print something else. Well, the same thing holds true in MySQL. We use these case statements, which I'll show you in just a moment, to do things like this. So over here, I have a genre category or a genre column that is not in our database. And what I've gone and done is basically said, print out title and release year, which are very straightforward. But then take that release year, and if it's greater than 2000, genre should be equal to modern lit. If it's less than 2000, then it should be 20th century lit. Very, very simple genres. We could easily expand that, or maybe genre is the wrong word. Maybe period is better, or era. But I called it genre. It's a lot of work to change these slides now, so we'll just call it that. But again, what's happening here is we have a conditional statement. This depends on this. So if we change release year of the namesake to be 1990, this would also change to be 20th century lit. So it's adding in logic. a new layer of complexity that we haven't seen how to do to make these decisions. And we're not limited just to two, of course. We could break it up into a whole bunch of things, and I'll show you a few more examples. But let's first identify how this works. And I'll warn you, there's kind of a lot of syntax. Okay, so here it is. This is what results in what we just saw. So the beginning and end are the same. Select title and release year from books. But then we have this whole case thing, 4 separate lines. They don't have to be separate, of course, like anything in MySQL, but it makes it a lot easier to see what's related to what. First thing that we have is case. That's the word that says this is a case statement. It's going to consist of a couple of points of logic that will spit one thing out. And that thing ends right here. And then I have an as. So I don't have to have as genre. Remember, that's called an alias. But if I left that off, it would look really, really gross when it printed out in the table, because instead of genre here, it would say this entire thing, which would make the table gigantic. It would go way off the page and would ruin our formatting. So you usually want to use as. But then the more important part is what we have right here. So case statements take the following form. There's always a when, at least one, and then there's an else, as well as the opening case and the closing end. So let's step through what this says. When release year is greater than or equal to 2000, then return modern lit. And when I say return, it's a programming term, but basically means spit out. Think of it as just making genre equal to modern lit. So that happens when release year is greater than or equal to 2000. Then we have an else, which is otherwise, we're going to return 20th century lit. So this is basically saying if it's greater than 2000, if it was released in the 2000s, then make genre modern lit. Otherwise, it was released in the 1900s, so we're going to print out 20th century lit for genre. And that's how we end up with this. So we have this bit of conditional logic where genre changes depending on the value of release year. So let's actually try this now. Run it. And you can see we get the namesake 2003 is modern lit. Interpreter of maladies, however, is from 1996. And so we get 20th century lit. And I will show you if I get rid of the as, it's a nightmare, because if you look at what we have as our headers here, we have title, release year, and then we have case, when released, greater than 2000, then modern lit, else, blah, 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 blah. So you definitely want to use as when you can. Okay, so that's one example. But I do think this one benefits from a couple because it's a bit weird, especially if you don't come from a programming background, so don't panic if you're not comfortable with this type of logic. But if you are, it's very similar. If you're not, it's kind of a big new idea. So here's another one. What I've done here, printed out title, and then stock quantity. And then I'm using stock quantity to then print a graphical representation of how much stock we have. So 1 star is things that are lower in stock, 2 star has a medium level of stock, and 3 stars means we have a lot of stock. And I can't remember the exact numerical breakdown where that happens. I believe if it's 0 to 50 copies, we have 1 star. If it's 50 to 100, we have 2 stars. And then if it's 100 or more, we have 3 stars. So it looks like this. So let me show you. Select title and stock quantity from books. Again, beginning and end is the same. Then we have our case, and then the end of the case with this alias stock. And so that's just going to give us stock right here. And then the important part. So when stock quantity is between 0 and 50, and we don't have to use between, we could use what we saw earlier, our logical and. We could say when it's greater than and equal to 0 and stock quantity is less than 50, then blah, blah, blah. But it's much easier to use between. So when stock quantity is between 0 and 50, then stock is 1 star. So that's how we end up with 1 star. But if that's not true, then it moves on to the next one. So if stock quantity is 100, this is false. So it ignores it. And it tries this. Well, is stock quantity between 51 and 100? If it is, then stock is going to be 2 stars. And if it's greater, let's say it's 153, well, this is false and this is false. So it goes to this last one, else, has no other choice. This is otherwise. If nothing else above was true, well, then this one is 3 stars. So it goes through and it does that for every single one. So we end up with 1, 2, and 3 stars. So hopefully you're getting the idea here. It's pretty powerful. It allows us to make decisions or have different outcomes depending on our data. One thing I definitely need to point out, because I can see this as being confusing, you don't have to have stock quantity printed out in order to reference it in your case statement. Or back here, I don't have to work with release year up here in order to work with it in the case statement. So let's actually copy this one over and run it. Make some space. Here we go. Okay, so we see the same thing. But just to show you, I'm not going to use stock quantity up here. I'm just going to select the title and our stock visualizer. And there we go. So I just wanted to show you, you don't have to have stock quantity referenced in order to use it inside of your case. And another point I should make is you're not limited in this number of how many conditions we could have. So if we wanted to, we could have another one here when stock quantity is between what would we do, 101 and 150, let's say. Then it's 3 stars. Otherwise, it's higher than that, so we'll say 4 stars. So let's try that. And let's actually add stock quantity back in. It makes sense to be able to see that. And let's copy it over and run it this time. And now we have 1 star, 2 star, we've got 4 stars for 154 and 3 stars for 104. So my point is that you're not limited. Another thing that trips me up personally is I'm inclined to put commas here just because most things in MySQL are separated by commas. If you have a list of values or a list of anything, that will break it. So no commas there. It trips me up all the time. Okay. So one other thing I did want to address is that we could make it shorter if we don't use between. And the way that we can do that is by taking advantage of the execution order of things. So let me show you. Here's the same exact outcome as this line of code where we have 1, 2, and 3 stars. However, it's much shorter because what's happening here? So if it's less than or equal to 50, then we're done. We get 1 star. If that's not true, that means already it's greater than 50. So if this line is running, we know for sure stock quantity is greater than 50. They go in order. So we don't have to necessarily add this between because we know, all right, it's definitely greater than 50. So we can just take advantage of that and just say, okay, well, is it less than or equal to 100, which is the equivalent of saying, is it between 50 and 100? If it is, then it's 2 stars. But if it's not less than or equal to 100, then that means it's greater than 100. And so we get 3 stars. So this is more just showing you a way of cleaning it up if you wanted to. So you don't have to use between. And you can see we get the exact same outcome, 1, 2, and 3 stars. We don't have to use those longer between statements. Although some people would argue between is easier to read. It's more semantic, more understandable when you look at it rather than working with this. Definitely up for debate. So that wraps up this section on case statements, which hopefully you see what I mean when I say they're both very useful, but possibly a little intimidating, especially syntactically. There's a lot there. So definitely take some time on the next couple of exercises. I'm going to have a few that require you to write case statements. Hopefully you'll get some practice there, and you'll see how powerful they are. With that said, we're moving on to exercises. All right, so you probably guessed it, either because in the last video I told you, or because of this gigantic text here, it's your turn to try putting this into practice. So we got a couple of exercises. They range from trivial, simple logic questions all the way up to more complex case statements. So I encourage you to go through all of them, especially the case statements towards the end, but hopefully you don't lose interest before then. Oh, and one thing. This is the last time you have to work with those darn books. Last time that books data, unless you want to keep working with it, you can definitely play around with it. But I'm getting pretty sick of it. I imagine you are. And the good news is we're now moving on to join tables, which allows us to get much more complex and real life data, things that are more accurate and realistic. And that's really exciting. So get excited if you're not. All right, so here's the first couple. Evaluate the following. Now try doing them. Don't just copy them and paste them in and hit enter. Actually walk through and evaluate what you think the result is. So the first one, select 10 not equal to 10. Is that true or false? 0 or 1? Next, select 15 greater than 14 and 99 minus 5 less than or equal to 94. True or false? 0 or 1. Finally, select 1 in 5, 3 or 9 between 8 and 10. True or false? So do those and then move on to these code-based challenges. So the first one here is select all books written before 1980, and that does not include 1980. So everything up to 1980, but not 1980. Once you've done that, move on. I've got some beautiful red text, really expanding the color palette. Select all books written by Eggers or Chabon. I don't know how you say his name, honestly. That guy. Great author. Well, I just Googled it, and apparently it's pronounced Chabon. So, select all books written by Eggers or Chabon. Makes sense now, I think about it. Now, onto the beautiful yellow. Select all books written by Lahiri, published after 2000. So, books written by Lahiri released after 2000. Then, select all books where the page count is between 100 and 200 pages. So our middle length or short books, those are pretty short, between 100 and 200 pages. Next, select all books where the author last name starts with a C or an S. So this one, there's a couple of ways of approaching it. I'll let you discover what works best. You may want to you'll need to use things that we've learned in the past, especially when we're working with strings. So you may want to go back or just go to the string documentation to figure out how to do this. Select all books where the author last name starts with a C or an S. Those are my initials, so maybe I'm crazy and I just want books that who are written by authors who start with my initials. I don't know. Now, moving on to the main event, our wonderful case statements. So here is another example. This is done using a case statement. And let me explain it. So we've got title and the author last name. But then we've got a type over here. What type of book is it? Which I'm really bad at this. This should just be called genre. It doesn't matter though. Basically, the way that it works, if the title contains the word stories, we're calling it short stories. So as you can see, where I'm calling from, selected stories, is categorized as short stories. Where what we talk about when we talk about love, great collection, is categorized as short stories because it contains stories. Same thing with Oblivion stories. But then there's another part. If the title is just kids, or it's a heartbreaking work of staggering genius, which I didn't write all the way up here because it's giant, but basically if it's this book or if it's this book, both are memoirs. So we have these two exceptions that you'll need to write in. Finally, everything else, which hopefully sounds familiar, otherwise, everything else at the end is called a novel. And I know some of these aren't actually novels, like Consider the Lobster is more of an essay or collection of essays. 10% Happier is like a self-help book, but I didn't want to get too complex. So just to reiterate, if the title contains stories, type is short stories. If the title is exactly just kids or exactly a heartbreaking work of staggering genius, then it's memoir. Both great memoirs, by the way. And then finally, everything else is a novel. Okay, one more. This is a bit of a bonus. So it's more complex. You have to put a few things together. So we have title of the book and the author last name once again. But then there's this count section. And count, which we've already seen how to do, is a little different. It's not just saying 2 or 1 or 3. What it's actually doing, we can ignore the title part. Actually, you don't need to do that. Just focus on the last name of the author and the count. It's saying how many books each author has, how many they've written. So Carver has 2 books, Gaiman has 3 books, Harris Dan Harris or Frida Harris, they each have one book. Jhumpa Lahiri has 2 books, and so on. But not only is it printing the number, but there's also the properly pluralized books or book following it. So 1 book, singular, 2 books, 3 books, 1 book, and so on. So you'll need to use a couple things. I can give you hints. If you don't want the hints, then stop right now. But the hints are, you need to use group by. You need to also use a case statement to generate this right here. But it is a bonus because you do need to combine a couple things. It's a decent amount of work. Okay, so that's it. Once you finish that, burn all the books. We're done with them, whatever that means to you. I don't actually condone burning books, but if you want to get rid of the database, go ahead. Although you may want to refer back to it. This is more just me saying that we're done. We're done with the books. This is a turning point. We're moving on to some bigger and better data and to a pretty important section, which is joins. So I definitely recommend you take a break. But I will reiterate that in the solution video, which is coming up next. Okay, so let's go over. Hopefully you're still alive. It was maybe a bit of a challenging problem set. But if you're still here, let's go with these first 3. So evaluate the following. Select 10 not equal to 10. Well, 10 is equal to 10, so this should return false. We get 0. Next one, a little more complex. We've got an and, so remember that means both sides have to be true. Let's start with the left. Is 15 greater than 14? Yes, so that's true. But how about this side? 99 minus 5, it gives us 94. Is 94 less than or equal to 94? Yes, it's equal to. So that means both sides are true, meaning the whole thing is true, which we get 1. Finally, select 1 in 5, 3, or 9 between 8 and 10. So we've got or, means either side can be true to make the whole thing true. So let's start with this. Select 1 in 5, 3. Remember, I didn't show you this explicitly, but we saw how to use in, so you should know how it works. Is 1 in that set of 5, 3? No. So this side's false. But that doesn't nullify the whole thing. That doesn't falsify it. Because what's on the right side? Is 9 between 8 and 10? Yes, it is. So this is true, making the whole thing true. Let's try it. There we go. We get 1. So false, true, true. Next, select all the books written before 1980. So I didn't specify what part of the book. That's totally up to you. Let's just do title and released year so we can see that released year from books. And then the key thing is we want to do where released year is less than 1980 and not less than or equal to because it says non-inclusive. So less than where released year is less than 1980. Let's make sure it works. And there we go. All books written before 1980. Apparently we only have 1. Let's just actually verify that. It's kind of catching me off guard there. And it looks like that's the case. All we have is Cannery Row. Well, I apologize that we don't have more exciting data. Next up, select all books written by Eggers or Shavon, which I now know how to pronounce. So there's a couple ways of doing this. Let's start with the most straightforward maybe, which would be, and also let's do title and author last name. So again, I didn't specify what parts you had to select, so it's up to you, but this makes the most sense so we can see the author last names. So what we can do is select them where, and we can use an or, so we can do a double equality, where author last name is equal to Eggers or author last name is equal to Shavon. Where author L name is equal to Eggers or author L name is equal to Shavon, just like that. That's one way of doing it. And you can see we get those 4 books. However, we can also use in, because all that we're doing is trying to see if author L name is in the set of Eggers and Shavon. So we can combine them, basically say where author L name in that set. Copy that, And there we go, same results. So whichever you prefer. This one is a little bit easier to see, I guess. It's shorter, easier to edit. And if we wanted to add another author in, it's pretty simple. But this is also perfectly valid. Next, select all the books written by Lahiri published after 2000. So the first thing, we'll do title, and this time we'll do author, name, and released year from books. And we'll start by all books written by Lahiri. So where author name equals Lahiri. So we can start there. We know that this should work, but we get 2 books. And now we want only the ones published after 2000. So what we need is a logical and. So where author name is equal to Lahiri and released year is greater than 2000. And I didn't specify if it was inclusive or not. So based off of the language, published after 2000, we'll keep it as a greater than. If you put an equal sign there, it's not, you got it right, essentially. I didn't do a great job of clarifying that before, so either one works. Now we only get the namesake. Also, really great read. Next up, select all books with page counts between 100 and 200. So just like the problem we did back here, there's a couple of solutions. The first one is to use logical and. So we could do select title and page count, or just pages from books, where pages is greater than 100 and less than 200. So where pages, and we'll do greater than or equal to. Pages is greater than or equal to 100 and pages is less than or equal to 200. That's one way of selecting based off of a range. There we get these shorter books, but we could also use between, which maybe you gathered because of the language here. It screams out between, and that might simplify it a bit. So all we have to do is change it to where pages between 100 and 200. Nice, easy to read version. We get the same results. Okay. One thing, remember that this is inclusive. So if we didn't want to include 100 and 200, we could either do this, or we would have to change this to be 101 and 199 or something. Okay, so I'll leave it as 200. Moving on. Select all books where the author last name starts with a C or an S. So there's also a couple ways of doing this one. We'll start with the simplest one. So we want to select, and this time we'll do title and author name from books. And basically we want to, let's just type it out with pseudocode or English code. So where author name starts with C or author name starts with S. So those are not, that's not valid code. So how do we do this? There's a couple options. The first one is to just use like, if you're comfortable with that. Instead of starts with C, we can just say where author name like, and then we use the % sign to force the C to be at the beginning of the string. So remember that this says the string starts with C and then anything afterwards. So that's one way to say it starts with a C. And then we just do the same thing down here, like S with the % sign after that. And that should do it for us. So we get Chabon, Smith, Carver, Steinbeck, Saunders. Good collection of authors. However, there's another way, which is to use substring. So if you remember substring, or maybe you remember me complaining about how there's also an abbreviated sub-str version. So we could use that. So we could say where author name substr of author name, and we want 1, 1, which will give us the first character. We want to check where that's equal to C, or, and I'll just duplicate this whole thing, where it's equal to S. So we could do this, and we get the same thing. But there's yet another way to clean this up, which is to then, I'll just keep them all here so that you can see them all. We could go, and because we're checking these two values, we could also use in C, comma, S, just like that, and get rid of the or. So now we're saying select title and author L name from books where the first character of author L name is in the set of C or S. And we get the same result. So 3 different ways. Next up, moving on to case statements. So in this one, I tried to throw you for a little bit of a curveball because unlike the other case statements we saw where we were just using greater than and less than, there's a couple things you're doing here. So we're just working with title, but you're seeing if title is like stories, and then you're seeing if it exactly equals Just Kids or A Heartbreaking Work of Staggering Genius. So let's start off with the basics. Select title and author, L name, and we'll just do from books, just like that. And then we need our case statement syntax. So we're gonna have case, and I like to just put my end right in there, as well as my as, and I called it type, which I don't actually think is a great name. Genre would be better. But inside of here, we're gonna have our statements. So the first thing we're gonna do is figure out, okay, if title contains the word stories anywhere, type is short stories. So when title, like, and how do we write or express the fact that it can contain stories anywhere, not just at the beginning, but anywhere in there? Well, we use percent sign. So this means that it contains a string stories with anything afterwards, which technically we could have histories or something, which maybe is not what we want, but we can leave it at that. You could put a space here or something to make sure that it's just stories, but I'll keep it simple with stories like this. Then that's going to be short stories as our type. Okay, then we have another statement when title, and when title is exactly Just Kids or A Heartbreaking Work of Staggering Genius, we should print out memoir. So let's leave that part blank and just add in then memoir. So then how do we fill this part in? It's pretty straightforward. It's going to be a bit annoying. So how do we check if it's equal to Just Kids? When title equals Just Kids, or when title equals, and this is going to be very long, so I'm going to copy it. Where are you? Just like that. And I might shorten that, or I definitely would shorten it. So maybe it would be better to use like or something and search for a particular part rather than the entire name. But that was a problem here. Followed by our else, which is otherwise everything is a novel. So that's where this comes in. Else, novel, just like that. Now let's double check. We don't have any extra commas, which I said I sometimes do. Looks good. Let's try it out. And we get all novels except for Just Kids and A Heartbreaking Work of Staggering Genius. And then those are memoirs. And then we have 2 Raymond Carver collections of short stories and a David Foster Wallace collection. Okay, so that's it. And of course, you could clean this up. So you could have used in here, title equals, so you could say where title in Just Kids, comma, A Heartbreaking Work of Staggering Genius. You could use like, something like this, or title like Heartbreaking, although maybe we have multiple books with Heartbreaking in the title. So I'm going to leave that and move on to our final one. How do we make this happen? So again, what's happening, we're grouping things by author, and we're counting how many books each author has written. But we're not just printing that out, we're printing it along with a space and then the correctly pluralized version of books. So we'll start by just printing out, we can ignore title, just do author last name and count without the books part. So that should be review of group by and count. So we'll select author, L name, comma, count, star, from books, group by, and we need to group by author L name. So if we do this, oops, you'll see we end up with Carver has 2 books, Eggers has 3 books, and so on. We do have that problem with Harris having 2 books, so we need to make this more specific, where we also group by author first name. And now we have 2 different Harrises. Perfect. So now, how do we, instead of just printing count like this, how do we add in that variable, the changeable suffix, book or books? That uses the case statement. So I'm going to make some space here, and rather than just printing the count, we're going to add in our case. Case, end, and if you look at how I printed it, I just called it count. So end as count. Then what is the logic we're actually trying to do? Well, we're trying to figure out when the number of books, count star, is equal to 1, let's say, then we want to do something. Let's just say singular book. This isn't the right answer. Otherwise, we'll do books. Okay, so the logic is going down the right page. We're grouping things by author. Then we're having a case statement that says when the total count of the number of books that author has written is equal to 1, then count is book. And before, I forget, we are missing our thens. So when count equals 1, then book. That's very important. Now if we paste it. Okay, so we get Carver has books, Eggers has books, but each Harris has book. So we're close. But how do we get the number in there? And we need to use concat. Hopefully you guessed that. So we're going to concat. Basically, we want to take the number, which is going to be count, and we want to concatenate it with space book. Now, if we wanted to shorten this, we could just hard code this as 1 book, right? Because when count is equal to 1, then it's always going to be 1 book. This is the one where we have multiple books. We need to add in the number because it could be 2 books, it could be 10 books. So we'll concat the 2 pieces, which are going to be count, star, comma, and I know this looks like a lot here, so let's step through it. Concatenate the count with space books. So 2 books, 3 books. And that should do it. Let's double check. Here we go. Carver has 2 books. Shaban has 1 book. Harris has 1 book. Lahiri has 2 books. The only other improvement, I guess, to suggest would be to also put author first name, just to make it a little clearer. In the case of Harris, we now can see Dan Harris has 1 book and Frida Harris has 1 book. Jhumpa Lahiri has 2 books. All right. Quite a bit there. Hopefully you made it through. Time to move on. We can burn that part of us that's attached to the books. We are done. We're moving on to bigger, more exciting things. I highly recommend that you, if you're at your computer, get up and take a break because joins are a big section. Very important stuff coming up next, but a bit dense. So go for a walk if you'd like, or do whatever you need to do to get prepared to focus on joins.